What if our civilization isn't the first? What if the world has risen and fallen so many times that entire eras lie buried beneath the ocean, beneath the soil, and beneath our own collective memory? Close your eyes for a moment and imagine standing on a beach at twilight. The waves roll in, steady and ancient, carrying with them the salt of 1,000 forgotten storms. Beneath those waves, somewhere in the darkness where light cannot reach, there might be cities, streets where people once walked, temples where they prayed, markets where they laughed and argued and lived lives as real as yours. And above it all, the stars look down, silent witnesses to a story that repeats itself in ways we're only beginning to understand. We tell ourselves a comfortable story about human history. We say that civilization began around 10,000 years ago, when our ancestors learned to plant seeds and build permanent homes. Before that, we imagine scattered tribes of hunter-gatherers living simple lives beneath the stars, leaving nothing behind but stone tools and cave paintings. We draw a straight line from those early farmers to the pyramids, from the pyramids to Rome, from Rome to the Renaissance, and from there to the modern world. A steady climb upward, always forward, never back. But what if that story is incomplete? What if the line isn't straight at all but circular? What if humanity has climbed this mountain before, reached heights we can barely imagine, and then tumbled back down into darkness? What if the world has been wiped clean not once, but many times, and each time the survivors had to begin again with nothing but fragments of memory and whispers of what came before? The evidence for such cycles doesn't announce itself loudly. It hides in plain sight, scattered across the world in the form of stones that shouldn't exist, ruins that predate our timelines, myths that repeat themselves across oceans and centuries, and geological scars that speak of catastrophes beyond imagination. To see this evidence requires a different kind of looking. Not the focused gaze of the specialist, but the soft peripheral vision of someone willing to see patterns in the shadows. Tonight, we're going to explore that possibility together. We're going to walk through ancient ruins in the quiet hours before dawn. We're going to listen to myths told around fires that burned thousands of years ago. We're going to examine the earth itself, reading its layers like pages in a book written in stone and ice. And we're going to ask questions that have no easy answers, questions that might change the way you see the world when you wake up tomorrow morning. How many civilizations came before us? What knowledge vanished with them? And how many times has humanity had to start again from nothing? Let's begin where the story gets strange, in the places where the stones remember things we've forgotten. There's a hill in southeastern Turkey, not far from the Syrian border, where the earth keeps secrets that shouldn't exist. The locals call it Gobekli Tepe, which means potbelly hill in Turkish, an unremarkable name for a place that has quietly rewritten everything we thought we knew about the dawn of civilization. For thousands of years this hill looked like any other. Shepherds grazed their flocks on its slopes. The wind swept across its grasses. The sun rose and set day after day, century after century, and the hill kept its silence. Then, in the 1990s, archaeologists began to dig, and what they found beneath that ordinary hillside was anything but ordinary. Massive stone pillars emerged from the earth, arranged in circles like the ribs of some enormous creature. Each pillar stood twice the height of a man, carved from limestone blocks that weighed as much as 10 tons. The pillars were decorated with intricate reliefs: foxes, lions, scorpions, vultures, and serpents, all rendered with an artistry that spoke of skilled hands and patient hours. The circles formed temples, or gathering places, or something we don't yet have a word for. And when the archaeologists dated the site, they discovered something that made no sense at all. Gobekli Tepe was built 11,000 years ago, maybe 12,000, maybe older still. The deeper they dig, the older it gets, and they've only excavated a fraction of what lies beneath that hill. Think about what that means. 11,000 years ago, According to our standard timeline, humans were supposed to be nomadic hunter-gatherers. They lived in small bands, following herds of animals across vast landscapes, sleeping under the stars or in temporary shelters. They had no cities, no agriculture, no written language, no complex social structures. They were, we've been told, at the very beginning of their journey towards civilization. And yet here, on this hill in Turkey, someone organised hundreds of people to quarry massive stones, transport them up a hillside, carve them with sophisticated imagery, and arrange them into structures that required planning, coordination, and a shared vision that could span generations. This wasn't the work of a few individuals, this was a society, a culture with beliefs, rituals, and the ability to mobilise labour on a scale that shouldn't have been possible for people who were supposedly just learning to settle down. The stones at Gobekli Tepe are older than the pyramids by 6,000 years. They're older than Stonehenge by 7,000 years. They're older than pottery, older than the wheel, older than agriculture itself. In fact, the evidence suggests that agriculture might have developed because of places like Gobekli Tepe, not the other way around. Perhaps people settled down to be near these sacred sites, and only then did they begin to plant crops and domesticate animals. Perhaps civilization didn't begin with farming. Perhaps it began with something else entirely. Something we've lost. Something that drove people to move mountains, before they'd even learned to plant wheat. Stand among those pillars in your mind. Feel the weight of the stones, the precision of the carvings, the sense of purpose that radiates from every surface. These weren't crude monuments thrown together by people who barely understood the world around them. These were the work of minds as sharp as ours, hands as skilled as ours, hearts as full of wonder and fear and hope as ours. And if they could do this 11,000 years ago, what else might they have done? What else might have existed that we haven't found yet, or that time has erased completely? The mystery deepens when you realise that Gobekli Tepe was deliberately buried. Around 8,000 years ago, someone filled in those circles with dirt and rubble, covering the pillars completely, transforming the temples into a hill. Why would anyone do that? Why would a society invest so much effort into building something magnificent, only to bury it and walk away? Was it an act of reverence, preserving something sacred for a future that never came? Was it an act of fear, hiding something that had become dangerous? Or was it simply the end of an era, the closing of a chapter in a story we can no longer read? We don't know. The stones don't tell us. They only stand there in their circles, patient and silent, waiting for us to ask better questions. But Gobekli Tepe isn't alone. Once you start looking, you find these anomalies everywhere, scattered across the world like pieces of a puzzle that no one remembers putting together. Off the coast of Japan, near the island of Yonaguni, divers discovered something in 1987 that still sparks debate decades later. Beneath the clear blue waters of the Pacific, massive stone structures rise from the seafloor. Terraces, platforms, steps, and what appear to be carved channels and pathways. The formations are geometric, angular, precise. They look like the ruins of a city, or a temple complex, or some kind of ceremonial centre that was swallowed by the sea. Geologists argue about whether Yonaguni is natural or artificial. Some say the formations are simply the result of erosion and tectonic activity, that the ocean carved these shapes from the bedrock over millions of years. Others point to the right angles, the symmetrical terraces, the apparent tool marks, and ask how nature could be so precise. The debate continues, but here's what we know for certain. If Yonaguni is artificial, it was built when that area was above water, and the last time that area was above water was at the end of the last ice age, more than 10,000 years ago. 10,000 years ago. Before the pyramids, before Sumer, before any civilization we officially recognise, and yet there it sits, beneath the waves, waiting for us to decide whether it's a monument or a mirage. Move west, across the Indian Ocean, to the coast of Gujarat in India. Ancient texts speak of a city called Dwarka. a golden city built by the god Krishna, a place of such splendour that it was said to have been swallowed by the sea after Krishna's death. For centuries, scholars treated this as pure mythology, a beautiful story with no basis in reality. Then, in the 1980s and 1990s, marine archaeologists began exploring the waters off the coast of Gujarat, and they found something extraordinary. Beneath the waves, they discovered the remains of a city, stone structures, walls, what appeared to be streets and buildings all resting on the sea floor. They found pottery, artifacts, and evidence of human habitation. Carbon dating suggested that some of these structures were thousands of years old, far older than the historical period when Dwarka was supposed to have existed according to conventional timelines. The discovery raised uncomfortable questions. If the myths were right about the city being swallowed by the sea, what else might they be right about? How many other legends are we dismissing as fantasy, when they might be memories of real places, real events, real civilizations that vanished beneath the waves? The ocean is a vast graveyard. Sea levels have risen and fallen dramatically over the course of human history, and during the last ice age, the coastlines of the world looked completely different than they do today. Vast stretches of land that are now underwater were once dry, habitable, and potentially home to thriving communities. When the ice melted and the seas rose, those lands were flooded, and anything built on them was lost. If there were cities on those ancient coastlines, and why wouldn't there be, given that humans have always been drawn to the sea, then they're gone now, buried under hundreds of feet of water, slowly being eroded by currents and covered by sediment. How many cities lie beneath the waves? How many harbours, temples, libraries and homes? How many stories were written on materials that couldn't survive the salt and the pressure and the endless patient work of the ocean? We'll never know, because the sea keeps its secrets well. But the anomalies aren't limited to the ocean floor. Some of the strangest ruins stand in plain sight, on dry land, challenging us to explain them. In the mountains of Lebanon, in the ancient city of Baalbek, there's a Roman temple complex built on a foundation that predates Rome by thousands of years. The Romans built magnificent structures there, temples to Jupiter, Bacchus and Venus, with columns that soar toward the sky and courtyards that speak of imperial grandeur. But beneath those Roman temples lies something else, something the Romans themselves couldn't have built. The foundation of Baalbek consists of massive stone blocks, some of which weigh over 800 tons. 800 tons! That's the weight of more than 100 elephants, or 3 fully loaded 747 airplanes. These blocks are so large that modern engineers struggle to imagine how they were moved, let alone lifted and placed with such precision that you can't slide a piece of paper between them. The Romans were master builders, but even they didn't work with stones this size. Their largest blocks were impressive, but nothing compared to the megaliths at Baalbek. So who built the foundation? The Romans built on top of it, but they didn't build it. Local legends say the site was ancient even in Roman times, that it was built by giants, or by a race of people who lived before the flood. Archaeologists have dated the foundation to the Bronze Age, maybe earlier, but that only pushes the mystery back a few thousand years. It doesn't explain how a Bronze Age culture, working with copper tools and wooden rollers, managed to move and place stones that would challenge modern cranes and hydraulic lifts. The same question echoes across the world. In Peru, at the fortress of Sacsayhuaman overlooking Cusco, massive stones fit together so perfectly that the joints are nearly invisible. Some of these stones have dozens of angles, each one cut to match the stone next to it with such precision that the whole structure locks together like a three-dimensional puzzle. The Inca built Sacsayhuaman, or so we're told, but the Inca themselves said they didn't build it. They said it was already there when they arrived, built by a people who came before them, a people whose knowledge had been lost. In Egypt, the Great Pyramid of Giza contains approximately 2.5 million stone blocks, each weighing several tons, fitted together with such accuracy that the entire structure is aligned to true north within a fraction of a degree. The conventional explanation is that the pyramid was built as a tomb for the pharaoh Khufu around 4,500 years ago, using copper tools, wooden sledges, and an enormous workforce. But the precision of the construction, the astronomical alignments, the sheer scale of the undertaking, all of it suggests a level of knowledge and capability that seems almost impossible for a civilization that had only recently emerged from the Stone Age. And then there are the questions that don't get asked often enough. Why do so many ancient cultures separated by oceans and thousands of miles build pyramids? Why do they align their structures to the stars? Why do they work with stones so massive that moving them seems to defy logic? Is it coincidence? Or is it memory? An echo of something older, a shared knowledge that was passed down through generations, fragmenting and fading but never quite disappearing. These ruins don't fit comfortably into our timeline. They're too old, too sophisticated, too ambitious. They suggest that the people who built them had knowledge we don't credit them with, or that they inherited that knowledge from someone who came before. They hint at a history that's deeper and stranger than the one we've written in our textbooks, a history where the line between myth and reality blurs, and where the past might be far more complex than we've ever imagined. But every ending hides the seeds of a beginning, and every mystery leads to another question. If these ruins are the remnants of something older, something we don't fully understand, then what happened to the people who built them? Where did they go? And why did their knowledge disappear? To answer that, we need to listen to the stories they left behind, the myths, the legends, the tales told around fires in the long nights when the world was young, and memory was all that stood between humanity and oblivion. Every culture on Earth has a flood story, every single one. From the mountains of Tibet to the jungles of the Amazon, from the islands of the Pacific to the deserts of the Middle East, people tell tales of a time when the waters rose and covered the world, when the sky opened and the rain fell for days or weeks or months, when the seas surged over the land and drowned everything, leaving only a handful of survivors to rebuild. The details vary, but the core of the story remains the same. There was a world before this one. It was destroyed by water. A few people survived, usually because they were warned by a god, or because they built a boat, or because they climbed to the highest mountain. And from those survivors, the world began again. In Mesopotamia, the Epic of Gilgamesh tells of Utnapishtim, a man who was warned by the god Ea that a great flood was coming. Utnapishtim built a boat, sealed it with pitch, and filled it with his family, his animals, and the seeds of all living things. The flood came, and the waters rose until they covered the mountains. For 6 days and 6 nights the storm raged, and when it finally ended, Utnapishtim's boat came to rest on a mountain peak. He sent out a dove, then a swallow, then a raven, and when the raven didn't return, he knew the waters had receded. He made a sacrifice to the gods, and they blessed him with immortality for preserving life through the deluge. In the Hebrew Bible, the story is nearly identical. Noah is warned by God that a flood will destroy the earth. He builds an ark, gathers his family and pairs of every animal, and rides out the storm. The waters cover the mountains. The rain falls for 40 days and 40 nights. When the flood recedes, the ark comes to rest on Mount Ararat. Noah sends out a dove, and when it returns with an olive branch, he knows the world is ready to be inhabited again. God makes a covenant with Noah, promising never to flood the earth again, and sets a rainbow in the sky as a sign. In India, the Matsya Purana tells of Manu, the first man who was warned by a fish that a great flood was coming. The fish told Manu to build a boat and fill it with the seeds of all plants and pairs of all animals. When the flood came, the fish, who was actually the god Vishnu in disguise, towed Manu's boat to safety, guiding it through the raging waters until it came to rest on a mountain peak. From Manu and his boat, the world was repopulated. In Greece, the myth of Deucalion and Pyrrha tells of a flood sent by Zeus to destroy humanity because of their wickedness. Deucalion, warned by his father Prometheus, built a chest and filled it with provisions. He and his wife Pyrrha floated on the waters for 9 days and 9 nights, until the chest came to rest on Mount Parnassus. When they emerged, they found the world empty and lifeless. They prayed to the gods for guidance and were told to throw the bones of their mother over their shoulders. They realized this meant stones, the bones of the earth, and when they threw stones behind them, the stones became people and the world was repopulated. In China, the story of Gun Yu tells of a great flood that covered the land for generations. The hero Gun tried to stop the flood by building dams, but he failed and was executed. His son Yu succeeded where his father had failed, not by blocking the waters but by dredging channels and guiding them to the sea. Yu's flood lasted for years, and when it finally ended, he became the founder of the Xia dynasty, the first dynasty of China. In the Americas, the Hopi people tell of multiple worlds that came before this one, each destroyed when humanity became corrupt. The third world was destroyed by water, a great flood that covered the earth. The people who survived did so by climbing into hollow reeds and floating on the waters until they found land again. The Aztecs told of 4 previous worlds, each destroyed by a different catastrophe. The 4th world ended in a flood that turned people into fish. The Inca spoke of a time when the waters rose and covered the mountains, and only those who climbed to the highest peaks survived. In Australia, Aboriginal stories speak of a time when the sea rose and swallowed the land, when the coastlines changed and islands were created. These stories are so specific that geologists have been able to match them to actual sea level changes that occurred thousands of years ago, suggesting that these oral traditions have been passed down for 10,000 years or more, preserving memories of real events that happened at the end of the last ice age. The flood myths are too widespread, too consistent to be pure coincidence. They span cultures that had no contact with each other, that developed independently on opposite sides of the world. They predate written history, existing as oral traditions long before anyone thought to write them down, and they all tell the same story. The world was destroyed by water, and humanity had to start over. So what are we to make of this? Are these myths simply the result of local floods, rivers overflowing their banks, storms that seemed apocalyptic to people who had never seen anything like them? That's the conventional explanation, and it makes sense for some of the stories. But it doesn't explain why the myths are so similar, why they all speak of a global catastrophe, why they all describe waters that covered the mountains and destroyed the entire world. Or could these myths be memories? Could they be the oral history of a real event passed down through generations, embellished and mythologized but rooted in something that actually happened? Could there have been a time when the seas rose dramatically, when coastlines were flooded, when entire regions were submerged, and the survivors told their children and grandchildren about the world that was lost? The geology supports this possibility. At the end of the last ice age, roughly 12,000 years ago, the world underwent dramatic changes. Massive ice sheets that had covered much of North America, Europe and Asia began to melt. The water from those ice sheets had to go somewhere, and it went into the oceans. Sea levels rose by more than 300 feet over the course of several thousand years. That's not a gradual, imperceptible change. That's a transformation that would have been visible within a single human lifetime. Imagine living on a coastline 12,000 years ago. Your people have lived there for generations. You know every inlet, every beach, every fishing spot. The sea is your livelihood, your highway, your source of food and trade. And then, over the course of decades, the sea begins to rise, slowly at first, then faster. The beaches you knew as a child are underwater. The islands where your grandparents were buried are gone. The river valleys where your people hunted are now bays. The land is shrinking, and there's nothing you can do to stop it. For people living through that change, it would have felt apocalyptic. It would have felt like the world was ending, because in a very real sense it was. The world they knew, the landscape they had adapted to, the places that held their history and their identity, all of it was being swallowed by the sea. And when they told their children about it, and their children told their children, the story would have grown, become more dramatic, more mythic, until it transformed into the flood legends we know today. But the flood myths aren't the only stories of destruction. Cultures around the world also speak of fire, of worlds destroyed by flames and ash, of skies that burned and mountains that exploded. In Norse mythology, Ragnarok is the end of the world, a time when fire and ice will consume everything, when the gods themselves will die, and the earth will sink into the sea. But after Ragnarok, the earth will rise again from the waters, green and fertile, and a new world will begin. In Hindu cosmology, the universe goes through endless cycles of creation and destruction. Each cycle lasts billions of years, and at the end of each cycle, the god Shiva performs the dance of destruction, burning away the old world so that a new one can be born from the ashes. The Maya believed in multiple creations, each one ending in catastrophe. The Popol Vuh, the sacred book of the Maya, describes how the gods created and destroyed several worlds before finally creating the one we live in now. One world was destroyed by fire, another by flood, another by darkness. In Greek mythology, the ages of man describe a series of declining eras: the Golden Age, the Silver Age, the Bronze Age, each one worse than the last, each one ending in destruction. The Bronze Age ended when Zeus sent a flood to wipe out humanity because of their violence and corruption. These myths of fire and destruction might also be rooted in real events: volcanic eruptions, asteroid impacts, solar storms. All of these could have created conditions that seem like the end of the world to the people who experienced them. The eruption of Mount Toba in Indonesia, 74,000 years ago, was so massive that it triggered a volcanic winter that lasted for years, dropping global temperatures and nearly driving humanity to extinction. The eruption of Thera in the Aegean Sea around 3,600 years ago destroyed the Minoan civilization and may have inspired the legend of Atlantis. The Younger Dryas impact hypothesis suggests that a comet or asteroid struck the Earth around 12,800 years ago, triggering rapid climate change and mass extinctions. These weren't myths. These were real events, catastrophes that reshaped the world and left scars in the geological record. And the people who survived them would have told stories, passed down warnings, tried to make sense of what had happened. Over time, those stories would have blended with other stories, merged with religious beliefs, transformed into myths. But at their core, they might be memories, fragmented, distorted, but real. And then there are the myths that speak not of natural disasters, but of something else. Myths of golden ages, of times when humanity lived in harmony with the gods, when knowledge was abundant and life was easy. The Greeks spoke of the Golden Age, a time when people lived like gods, free from toil and suffering. The Hindus speak of the Satya Yuga, the age of truth, when humanity was enlightened and virtuous. The Chinese speak of the age of the 3 sovereigns and 5 emperors, a time of wisdom and peace. The Egyptians believed that their civilization was a remnant of a much older one, that the gods had once walked among men and taught them the arts of civilization. These myths suggest that humanity didn't start from zero. They suggest that there was a time when knowledge was greater, when civilization was more advanced, and that something happened, a catastrophe, a war, a collapse, that caused that knowledge to be lost. The survivors had to rebuild, but they did so with only fragments of what came before, like children trying to reassemble a shattered vase with half the pieces missing. Could that be true? Could there have been a civilization before ours, one that rose to great heights and then fell, leaving only myths and ruins behind? The idea seems fantastical, but the more you look at the evidence, the anomalous ruins, the flood myths, the geological catastrophes, the more it starts to seem possible. Not certain, but possible. And possibility is where all the best questions begin. But if civilizations have risen and fallen before, if the world has been reset multiple times, then we need to understand the forces that could cause such resets. We need to look at the Earth itself, at the cycles of ice and fire, at the cosmic events that can reshape continents and extinguish species. We need to understand that the world is not as stable as it seems, that the ground beneath our feet is constantly moving, and that the sky above us is not as empty as it appears. The Earth has a rhythm, a pulse that beats across millennia. It's a rhythm of ice and warmth, of glaciers advancing and retreating, of climates shifting and ecosystems transforming. We call these cycles ice ages, and they've been happening for millions of years, long before humans walk the Earth. An ice age isn't a single event. It's a period of time when the Earth's climate cools, and ice sheets expand from the poles toward the equator. Within each ice age, there are glacial periods, when the ice advances, and interglacial periods, when the ice retreats. We're living in an interglacial period right now, a warm spell between glaciations. The last glacial period ended about 11,700 years ago, and before that, ice sheets covered much of North America, Europe, and Asia. Imagine what the world looked like during the last glacial maximum, around 20,000 years ago. Ice sheets more than a mile thick covered Canada, the northern United States, Scandinavia, and northern Asia. So much water was locked up in ice that sea levels were 300 feet lower than they are today. The coastlines extended far beyond where they are now. Land bridges connected continents. You could walk from Siberia to Alaska, from Britain to mainland Europe, from Southeast Asia to Australia. The climate was colder, drier, harsher. Deserts expanded. Forests shrank. Many species went extinct, unable to adapt to the changing conditions. And then, around 15,000 years ago, the ice began to melt. The climate warmed, the glaciers retreated, and the world transformed. Sea levels rose, flooding the coastal plains and creating the coastlines we know today. Rivers swelled with meltwater. Lakes formed and disappeared. The landscape was in constant flux, and any human communities living through that change would have had to adapt or perish. This wasn't a gradual, gentle transition. The warming happened in fits and starts, with periods of rapid change punctuated by sudden reversals. Around 12,800 years ago, the climate suddenly plunged back into glacial conditions for more than 1,000 years, an event called the Younger Dryas. Temperatures dropped, ice sheets advanced again, and the world that had been warming suddenly turned cold. Then, just as suddenly, the cold ended, and the warming resumed, even faster than before. What caused the Younger Dryas? Scientists have debated this for decades. Some believe it was caused by a massive influx of fresh water into the North Atlantic, disrupting ocean currents and triggering a climate shift. Others point to volcanic eruptions, solar variations, or changes in the Earth's orbit. And some researchers have proposed a more dramatic explanation, that a comet or asteroid struck the Earth, triggering wildfires, atmospheric changes, and rapid cooling. The Younger Dryas impact hypothesis is controversial, but it's supported by intriguing evidence. Researchers have found a layer of sediment dating to the start of the Younger Dryas that contains high concentrations of platinum, nanodiamonds, and other materials that are typically associated with extraterrestrial impacts. They've found evidence of widespread wildfires and sudden extinctions of megafauna. Mammoths, saber-toothed cats, giant ground sloths, and dozens of other species that had survived previous climate changes, but couldn't survive this one. If an impact did occur, it would have been catastrophic. Imagine a comet fragmenting in the atmosphere and raining down over North America, triggering massive explosions, wildfires that consumed entire forests, and a cloud of dust and debris that blocked out the sun. The immediate effects would have been devastating, but the long-term effects would have been even worse. The dust and soot in the atmosphere would have caused temperatures to plummet, triggering the Younger Dryas cold period. Any human populations living in the affected areas would have been decimated, and those who survived would have faced a world that had been transformed overnight. This is speculation, of course. The impact hypothesis is still being debated, and many scientists remain skeptical. But whether the Younger Dryas was caused by an impact, a climate shift, or some combination of factors, The result was the same: a world in chaos, a climate in flux, and human populations struggling to survive. And this wasn't the only time the Earth has been reshaped by catastrophe. The geological record is full of events that would have seemed apocalyptic to anyone who lived through them. 74,000 years ago, Mount Toba in Indonesia erupted in one of the largest volcanic explosions in the last 2 million years. The eruption injected more than 600 cubic miles of ash and rock into the atmosphere, creating a volcanic winter that lasted for years. Temperatures dropped by as much as 15 degrees Celsius in some regions. Sunlight was blocked, crops failed, and ecosystems collapsed. Genetic evidence suggests that the human population was reduced to as few as 10,000 individuals, a bottleneck so severe that we nearly went extinct. The survivors were scattered, isolated, and forced to adapt to a world that had become hostile and unforgiving. 66 million years ago, an asteroid struck the Yucatan Peninsula in Mexico, creating the Chicxulub crater and triggering the extinction of the dinosaurs. The impact released energy equivalent to billions of nuclear bombs, triggering earthquakes, tsunamis, and wildfires that spread across the globe. Dust and debris filled the atmosphere, blocking out the sun and causing temperatures to plummet. The dinosaurs, which had ruled the Earth for more than 150 million years, were wiped out within a few thousand years. The world that emerged from that catastrophe was completely different from the one that came before. These events are rare, but they're not impossible. The Earth is constantly being bombarded by asteroids and comets, most of them small enough to burn, up in the atmosphere, but some large enough to cause significant damage. In 1908, an asteroid or comet exploded over Tunguska in Siberia, flattening 2,000 square kilometers of forest. If that explosion had occurred over a populated area, it would have killed millions. In 2013, a meteor exploded over Chelyabinsk in Russia, injuring more than 1,000 people and reminding us that the sky's not as empty as it seems. Volcanic eruptions are even more common. The eruption of Mount Vesuvius in 79 AD buried the Roman cities of Pompeii and Herculaneum under ash and pumice, preserving them for nearly 2,000 years. The eruption of Krakatoa in 1883 killed more than 36,000 people and was heard 3,000 miles away. The eruption of Mount Pinatubo in 1991 ejected so much ash into the atmosphere that it lowered global temperatures by 0.5 degree for 2 years. And then there are the supervolcanoes, volcanic systems so large that their eruptions can reshape continents. Yellowstone in the United States is a supervolcano that has erupted 3 times in the last 2 million years, each time covering much of North America in ash. If Yellowstone were to erupt today, it would be a global catastrophe, disrupting agriculture, collapsing economies, and potentially triggering a volcanic winter that could last for years. The Earth itself is unstable. The continents drift on tectonic plates, colliding and separating over millions of years. Earthquakes and tsunamis are constant reminders that the ground beneath our feet is not as solid as it seems. The magnetic poles wander, and every few 100,000 years they flip, reversing the Earth's magnetic field. During these reversals, the magnetic field weakens, exposing the Earth to higher levels of cosmic radiation and potentially disrupting navigation systems, communication networks, and even the behavior of animals. The Sun, too, is a source of potential catastrophe. Solar flares and coronal mass ejections can send massive bursts of charged particles toward the Earth, disrupting satellites, power grids, and communication systems. In 1859, a solar storm known as the Carrington event caused auroras to be seen as far south as the Caribbean and set telegraph systems on fire. If a similar event occurred today, it could cause trillions of dollars in damage and leave entire regions without power for months. These are the forces that shape the world, the cycles of destruction and renewal that have been playing out for billions of years, and if these forces have shaped the world in the past, if they've caused mass extinctions and climate shifts and catastrophic events that reshaped continents, then they could do so again. They could wipe out civilizations, erase entire eras of human history, and leave only fragments behind. Ruins, myths, and questions that future generations would struggle to answer. But here's the thing. These catastrophes don't have to be global to reset civilization. They don't have to kill everyone or destroy everything. They just have to be severe enough to disrupt the systems that hold civilization together. The trade networks, the food supplies, the knowledge systems, the social structures. Once those systems collapse, even a technologically advanced society can fall back into darkness within a few generations. History is full of examples. The Bronze Age collapse, around 3,200 years ago, saw the fall of multiple civilizations across the Mediterranean and Near East: the Mycenaeans, the Hittites, the Egyptians, the Babylonians. Trade networks collapsed, cities were abandoned, writing systems were forgotten, and the region entered a dark age that lasted for centuries. The cause is still debated. Some blame invasions by the mysterious sea peoples, others point to climate change, earthquakes, or a combination of factors. But the result was the same: a world that had been interconnected and prosperous suddenly fragmented, and much of the knowledge and culture of the Bronze Age was lost. The fall of Rome is another example. The Western Roman Empire, which had dominated Europe for centuries, collapsed in the 5th century AD, and Europe entered the Middle Ages, a period often called the Dark Ages because so much knowledge was lost. Libraries were destroyed, literacy declined, trade networks broke down, and technological innovations were forgotten. It took centuries for Europe to recover, and when it did, it had to rediscover much of what had been lost. The Maya civilization in Central America reached its peak around 800 AD, with magnificent cities, advanced astronomy, and a complex writing system. Then, within a few centuries, the cities were abandoned, the population declined, and the civilization collapsed. The cause is still debated: drought, warfare, environmental degradation, or some combination of factors. But the result was that much of Maya knowledge was lost, and when the Spanish arrived centuries later, they found only ruins and fragments of a once great civilization. These collapses weren't caused by asteroids or supervolcanoes. They were caused by more mundane factors: climate change, resource depletion, political instability, warfare, disease. But the effect was the same. Civilizations that had seemed invincible crumbled, and the knowledge they had accumulated was lost or forgotten. And if it can happen to them, it can happen to us. In fact, it's already happening, in small ways. Languages are going extinct at an alarming rate, taking with them entire worldviews and bodies of knowledge. Traditional skills, how to build without nails, how to navigate by the stars, how to survive in the wilderness, are being forgotten as we become more dependent on technology. If our technological systems were to fail, if the power grids went down, if the internet collapsed, if supply chains were disrupted, how many of us would know how to survive? How much of our knowledge exists only in digital form, vulnerable to a single solar flare or electromagnetic pulse? We like to think of ourselves as advanced, as immune to the forces that brought down previous civilizations. But we're not. We're just as vulnerable, just as dependent on systems that are more fragile than we realize. And if those systems were to fail, if we were forced to start over, how much of our knowledge would survive? How much would be lost? And what would future generations think of us if they found only ruins and fragments, if they had to piece together our story from myths and legends? The Earth has a rhythm, and that rhythm includes destruction. Ice ages, volcanic eruptions, asteroid impacts, climate shifts. These are not anomalies, they're part of the cycle. And if civilizations have risen and fallen before, if the world has been reset multiple times, then it's not because of some grand conspiracy or ancient aliens or lost super technology. It's because the Earth itself is a dynamic, unstable, constantly changing system, and any civilization that exists on it is subject to forces beyond its control. But that doesn't mean we're helpless. It means we need to understand the cycles, to recognize the patterns, to learn from the past so we don't repeat its mistakes. And to do that, we need to look at the evidence with open eyes, to ask uncomfortable questions, and to be willing to consider possibilities that don't fit neatly into our established narratives. Because the story of civilization might not be a straight line upward. It might be a spiral, a cycle of rise and fall, of knowledge gained and lost, of worlds built and destroyed. And if that's true, then we're not the first to walk this path. We're just the latest, and the question is whether we'll learn from those who came before, or whether we'll repeat their mistakes and become another layer in the geological record, another mystery for future archaeologists to puzzle over. There's a concept in archaeology called the archaeological horizon, the idea that certain artifacts, technologies, or cultural practices appear suddenly in the archaeological record without clear precursors. It's as if they emerge fully formed, with no developmental stages, no trial and error, no gradual evolution. And when you start looking for these horizons, you find them everywhere. Agriculture is one example. For hundreds of thousands of years, humans were hunter-gatherers, living in small bands, following herds of animals, gathering wild plants. Then, around 10,000 years ago, agriculture appeared almost simultaneously in multiple locations around the world. The Fertile Crescent, China, Mesoamerica, the Andes, New Guinea. Within a few thousand years, people were domesticating plants and animals, building permanent settlements and developing complex societies. It happened so quickly and in so many places at once that it's almost as if someone flipped a switch. The conventional explanation is that climate change at the end of the Ice Age made agriculture possible, and that different cultures independently discovered the same techniques. But that doesn't explain why it took so long for agriculture to develop, or why it appeared so suddenly, or why the techniques were so similar across cultures that had no contact with each other. What if agriculture wasn't invented? What if it was remembered? What if there had been agricultural societies before the Ice Age, societies that were wiped out by the climate shifts and catastrophes of the Younger Dryas, and the survivors passed down fragments of that knowledge? What if the sudden appearance of agriculture wasn't the beginning of civilization, but the resumption of it? The same question applies to other technologies. Pottery, weaving, metallurgy, writing. All of these appear suddenly in the archaeological record, often with a level of sophistication that suggests they weren't invented from scratch. The earliest pottery from Japan, dating to around 16,000 years ago, is intricately decorated, suggesting that the potters already had significant skill and experience. The earliest writing systems, cuneiform in Mesopotamia, hieroglyphics in Egypt, appear fully formed, with complex grammar and vocabulary, as if they were developed elsewhere and then introduced to these regions. And then there are the megalithic structures, the stone circles, the dolmens, the menhirs, the pyramids. These structures appear all over the world, built by cultures that supposedly had no contact with each other, and yet they share striking similarities. They're aligned to the stars, they're built with massive stones, they're often associated with burial or ritual. Why would cultures on opposite sides of the world, separated by oceans and thousands of miles, independently decide to build the same kinds of structures? The conventional explanation is convergent evolution, the idea that similar environmental pressures lead to similar solutions. But that doesn't explain the precision, the astronomical alignments, the sheer ambition of these projects. It doesn't explain why so many of these structures are older than we expect, or why they're so sophisticated for their supposed time period. What if these structures aren't independent inventions? What if they're echoes of something older? A shared tradition that was passed down through generations, fragmenting and evolving but never quite disappearing. What if the people who built Stonehenge and the people who built the pyramids and the people who built the stone circles of the Amazon we're all drawing on the same ancient knowledge, a knowledge that predates the civilizations we recognize. This is where the idea of a lost civilization becomes compelling. Not a civilization of advanced technology and flying machines and laser beams, that's the stuff of science fiction. But a civilization that had knowledge we don't credit them with. A civilization that understood astronomy, engineering, agriculture, and navigation. A civilization that built monuments and passed down traditions and left a legacy that survived even after they were gone. There's a theory, proposed by researchers like Graham Hancock and others, that there was a global maritime civilization during the last ice age, a civilization that thrived on the coastal plains that are now underwater. This civilization would have been well positioned to explore the world, to trade with distant cultures, to spread knowledge and technology, and when the ice age ended and the seas rose, this civilization would have been destroyed, its cities flooded, its people scattered. The survivors would have fled inland, carrying with them fragments of their knowledge, and those fragments would have seeded the civilizations that emerged in the millennia that followed. This theory is speculative, and it's not widely accepted by mainstream archaeologists, but it's not impossible. The coastal plains that are now underwater were prime real estate during the Ice Age. Flat, fertile, close to the sea, perfect for settlement. If there were cities on those plains, they're gone now, buried under hundreds of feet of water and sediment. We'll never find them unless we start looking in the right places, and even then the ocean is vast and the evidence is fragile. But there are hints. The submerged structures off the coast of Japan, India, and other locations. The flood myths that speak of cities swallowed by the sea. The sudden appearance of advanced knowledge in cultures that supposedly had no precursors. The similarities between megalithic structures on opposite sides of the world. None of this is proof, but it's suggestive. It's enough to make you wonder. And if there was a lost civilization, if the world has been reset before, then what does that mean for us? It means that we're not as unique as we think. It means that the knowledge we've accumulated, the technologies we've developed, the civilizations we've built, all of it could be lost, just as it was lost before. It means that we're part of a cycle, a pattern that repeats itself across millennia, and that the only way to break that cycle is to learn from the past and to preserve our knowledge for the future. But preserving knowledge is harder than it sounds. Knowledge isn't just information, it's context, it's understanding, it's the ability to apply information in meaningful ways. You can write down the formula for concrete, but if no one knows how to mix it, or why it's important, or how to use it, then the formula is useless. You can record the movements of the stars, but if no one knows how to interpret them, or why they matter, then the records are meaningless. This is why oral traditions are so important. For most of human history, knowledge was passed down through stories, songs, rituals, and apprenticeships. Elders taught the young, and the young became elders and taught the next generation. This system worked for thousands of years, but it's fragile. If a generation is lost through war, disease, or catastrophe, then the knowledge is lost with them, and once it's lost, it's almost impossible to recover. Writing helps, but writing has its own vulnerabilities. Books can be burned, libraries can be destroyed, languages can be forgotten. The Library of Alexandria, one of the greatest repositories of knowledge in the ancient world, was destroyed, and with it, countless texts that will never recover. The Maya codices, which contain the accumulated knowledge of Maya civilization, were burned by Spanish conquistadors, and only a handful survived. The knowledge of how to read Egyptian hieroglyphics was lost for more than 1,000 years, until the Rosetta Stone was discovered and scholars were able to decipher the script. And now, in the digital age, we face new vulnerabilities. Our knowledge is stored on servers, in the cloud, on hard drives that can fail, or be hacked, or be rendered obsolete. We assume that the internet will always be there, that our data will always be accessible. But what if it's not? What if a solar flare knocks out the power grid? What if a cyber attack wipes out our databases? What if the systems we depend on simply fail, and we're left with nothing but blank screens and corrupted files. The more advanced we become, the more fragile we are. We've built a civilization that depends on complex, interconnected systems, and if those systems fail, we don't have the knowledge or the skills to rebuild them. We've outsourced our memory to machines, and if the machines stop working, we're left with nothing. This is the paradox of progress. The more we advance, the more we have to lose, and if we lose it, if we're forced to start over, then we become just another layer in the archaeological record, just another mystery for future generations to puzzle over. They'll find our ruins, our artifacts, our monuments, and they'll wonder who we were and what we knew and why we disappeared. And maybe they'll tell stories about us, myths and legends that blend fact and fiction, that preserve fragments of our knowledge but distort it beyond recognition. And maybe, just maybe, that's what the myths we tell now are. Fragments of knowledge from civilizations that came before, distorted by time and retelling, but rooted in something real. Maybe the flood myths are memories of the rising seas at the end of the Ice Age. Maybe the myths of golden ages are memories of times when knowledge was greater and life was easier. Maybe the myths of gods and giants are memories of people who seemed godlike to those who came after. People who had knowledge and abilities that were lost when their civilization fell. We'll never know for certain. The past is gone, and all we have are fragments, ruins, myths, and questions. But those fragments are enough to make us wonder, to make us question the story we've been told, to make us consider the possibility that the world is older and stranger than we've imagined. And that's not a bad thing. Wonder is the beginning of wisdom. Questions are the beginning of knowledge, and the willingness to consider uncomfortable possibilities is the beginning of understanding. Because if civilization has restarted before, if the world has been reset multiple times, then we need to understand why. We need to understand the forces that cause civilizations to fall, the mistakes that lead to collapse, the vulnerabilities that we're ignoring. We need to learn from the past, not just to satisfy our curiosity, but to ensure that we don't repeat the same mistakes. And maybe, just maybe, we need to start thinking about how to preserve our knowledge for the future, how to ensure that if we do fall, if we are reset, then the next civilization won't have to start from zero. Maybe we need to build monuments that will last, to encode our knowledge in ways that can survive catastrophe, to create a legacy that will endure even if we don't. Because the Earth has a rhythm, and that rhythm includes destruction, but it also includes renewal, and every ending is also a beginning. There's a place in the desert of New Mexico where time feels different. It's called the Waste Isolation Pilot Plant, and it's a repository for nuclear waste, buried deep underground in salt formations that have been stable for millions of years. The waste stored there will remain radioactive for tens of thousands of years, long after our civilization has crumbled, long after our languages have been forgotten, long after anyone remembers what nuclear power was or why it was dangerous. And so, the people who built this facility faced an unusual problem. How do you warn future generations about the danger buried here? How do you communicate across millennia to people who might not speak your language, who might not understand your symbols, who might not even recognize that you were trying to warn them? They considered many options. They thought about building monuments, carving warnings in multiple languages, creating symbols that would be universally understood. But every option had problems. Languages change and die. Symbols are misinterpreted. Monuments can be destroyed or repurposed. And the more elaborate the warning, the more likely it is to attract curiosity rather than deter it. In the end, they settled on a multi-layered approach. Physical markers, written warnings, symbolic representations, and even the idea of creating a priesthood of knowledge keepers who would pass down the warning through oral tradition. But even with all these precautions, there's no guarantee that the message will be understood. There's no guarantee that future generations will heed the warning, or even recognize that there's something to be warned about. This is the challenge of preserving knowledge across time. It's not enough to record information. You have to ensure that the information can be understood, that it will be preserved, that it will be taken seriously, and the longer the time span, the harder the challenge becomes. The ancient Egyptians understood this. They built their monuments to last, carving their hieroglyphics deep into stone, creating structures so massive that they would endure for millennia. And it worked. The pyramids still stand, the hieroglyphics can still be read, and we have a window into their civilization that we wouldn't have otherwise. But even the Egyptians couldn't preserve everything. Their libraries are gone, their oral traditions are lost, and much of what we know about them comes from fragments and guesswork. The Maya tried a different approach. They recorded their knowledge in codices, books made from bark paper, filled with intricate glyphs and illustrations. But bark paper is fragile, and when the Spanish conquistadors arrived, they burned most of the codices, believing them to be works of the devil. Only 4 Maya codices survived, and with them only a fraction of Maya knowledge. The rest is lost, and we'll never know what it contained. The Inca didn't have writing at all, at least not in the way we understand it. Instead, they used quipus, knotted strings that recorded information through a complex system of knots, colours, and positions. Quipus could record numbers, dates, and possibly even narratives, but the system was so complex that only trained specialists could read them. When the Inca Empire fell, the knowledge of how to read quipus was lost, and now we have thousands of quipus that we can't decipher. They're records of a civilization, but records we can't read. This is the tragedy of lost knowledge. It's not just that information is lost, it's that entire ways of thinking, entire worldviews, entire systems of understanding are lost. And once they're gone, they're almost impossible to recover. But there are exceptions. There are cases where knowledge has survived against all odds, preserved through oral tradition, through hidden texts, through the dedication of people who refuse to let it die. The Aboriginal people of Australia have oral traditions that go back tens of thousands of years, preserving knowledge of landscapes, animals, and events that occurred during the last ice age. These traditions are so accurate that geologists have been able to use them to identify ancient coastlines and sea level changes. The knowledge was preserved because it was embedded in stories, songs, and rituals that were passed down from generation to generation, and because the culture valued that knowledge and made sure it was never forgotten. The Vedas, the sacred text of Hinduism, were preserved through oral tradition for thousands of years before they were written down. Priests memorized the text word for word, syllable by syllable, and passed them down through generations with such precision that the texts we have today are virtually identical to the originals. The knowledge was preserved because it was considered sacred, because it was embedded in ritual and practice, and because the culture created systems to ensure its transmission. The Library of Timbuktu in Mali contains hundreds of thousands of manuscripts, some dating back to the 13th century, preserving knowledge of science, mathematics, astronomy, medicine, and philosophy from the Islamic Golden Age. These manuscripts survived because they were hidden, protected, and valued by the people who owned them, even when the city was under threat. These examples show that knowledge can survive, but only if we make the effort to preserve it, only if we value it enough to protect it, only if we create systems that ensure its transmission. And that's the challenge we face now. We have more knowledge than any civilization in history, but we also have more ways to lose it. We need to think about how to preserve that knowledge, not just for ourselves, but for the future, for the civilizations that might come after us if we fall. Some people are already thinking about this. The Longnow Foundation is building a clock designed to run for 10,000 years, a monument to long-term thinking and the idea that we should be planning for the deep future. The Svalbard Global Seed Vault in Norway stores seeds from around the world, preserving genetic diversity in case of global catastrophe. The Memory of Mankind project is etching knowledge onto ceramic tablets that will last for millions of years, creating a permanent record of our civilization. These are small steps, but they're important. They represent a recognition that we're not permanent, that our civilization could fall, and that we have a responsibility to preserve what we've learnt for those who come after. But preservation isn't enough. We also need to understand why civilizations fall so we can avoid the same fate. And when you look at the history of collapsed civilizations, certain patterns emerge. Environmental degradation is a common factor. The Maya, the Anasazi, the Easter Islanders, all of them depleted their resources, deforested their lands, and degraded their environments to the point where they could no longer sustain their populations. They cut down the trees, exhausted the soil, and when the climate shifted or the rains failed, they had no buffer, no resilience. Their civilizations collapsed not because of external invasion or natural disaster, but because they destroyed the very systems that sustained them. Resource depletion is another factor. The Bronze Age collapse was partly caused by the disruption of trade networks that supplied tin, a crucial component of bronze. When those networks broke down, civilizations that depended on bronze for tools and weapons found themselves unable to function. The Roman Empire's expansion was fueled by conquest and plunder. But when there were no more lands to conquer, the empire couldn't sustain itself and eventually collapsed under its own weight. Social complexity is a double-edged sword. Complex societies can achieve great things, but they're also fragile. They depend on intricate networks of trade, communication, and governance. And if any part of that network fails, the whole system can collapse. The more complex a society becomes, the more vulnerable it is to disruption, and the harder it is to recover when things go wrong. Climate change has been a factor in many collapses. The Akkadian Empire in Mesopotamia collapsed around 200 years ago, possibly due to a prolonged drought. The classic Maya collapse coincided with a series of droughts that made agriculture difficult. The fall of the Western Roman Empire was accompanied by a period of cooling and crop failures. Climate change doesn't have to be dramatic to be devastating. Even small shifts can disrupt agriculture, trigger migrations, and destabilize societies. And then there's war, disease, and internal conflict. The Black Death killed a third of Europe's population in the 14th century, disrupting economies and societies. The Mongol invasions devastated civilizations across Asia and the Middle East. Civil wars and internal conflicts have brought down empires from Rome to China to the Aztecs. These factors often work together, creating a cascade of failures that no civilization can withstand. Environmental degradation weakens a society, making it vulnerable to climate change. Resource depletion leads to conflict and war. Social complexity makes it harder to adapt to changing conditions, and when multiple crises hit at once, even the strongest civilization can fall. This is the lesson of history. Civilizations are fragile. They rise quickly, but they can fall just as quickly. And when they fall, they often fall completely, leaving only ruins and myths behind. But here's the thing, we know this now. We have the benefit of hindsight, the ability to look at past civilizations and learn from their mistakes. We can see the patterns, understand the risks, and take steps to avoid the same fate. We can invest in sustainability, protect our environment, diversify our resources, build resilience into our systems. We can plan for the long term, think about the deep future, and create a civilization that's designed to last. Or we can ignore the lessons of history, continue on our current path, and hope that we'll be the exception, that we'll be the civilization that doesn't fall. But hope isn't a strategy, and ignoring the past doesn't make us immune to its patterns. The choice is ours. We can learn from the civilizations that came before, or we can become another layer in the archaeological record, another mystery for future generations to puzzle over. We can preserve our knowledge and build a legacy that endures, or we can let it all slip away, lost to time and catastrophe. And maybe that's the real question we should be asking, not whether civilization has restarted before, the evidence suggests it has, but whether we're willing to do what it takes to ensure that it doesn't have to restart again. whether we're willing to think beyond our own lifetimes, to plan for the deep future, to create a civilization that's sustainable, resilient, and designed to last. Because the Earth has a rhythm, and that rhythm includes destruction, but it also includes renewal. And every ending is also a beginning. The question is whether we'll be the ending or the beginning, whether we'll be the civilization that falls or the civilization that endures. There's a moment late at night when the world feels different. The noise of the day has faded, the distractions have quieted, and you're left alone with your thoughts. In that moment, the past feels closer somehow, as if the veil between now and then has grown thin. You can almost hear the echoes of voices from long ago, almost see the shadows of people who lived and loved and built and dreamed, just as you do now. And in that moment, you might find yourself wondering about them. Who were they? What did they know? What did they build and why did it fall? And what would they think of us if they could see us now, if they could see what we've built and what we've learned and what we're in danger of losing? The story of civilization is not a straight line. It's a spiral, a cycle of rise and fall, of knowledge gained and lost, of worlds built and destroyed. We like to think of ourselves as the pinnacle of human achievement, the culmination of thousands of years of progress. But the truth is more humbling. We're just one chapter in a much longer story, a story that began long before us and will continue long after we're gone. The ruins scattered across the world, Gobekli Tepe, Yonaguni, Baalbek, Sacsayhuaman, are not just relics of the past. They're reminders that we're not the first to walk this path, that others have come before us, and that they achieved things we still struggle to explain. They built monuments that have lasted for millennia, encoded knowledge in stone and myth, and left behind questions that we're only beginning to ask. The myths told around fires in the long nights, the flood stories, the tales of golden ages, the legends of worlds destroyed and reborn, are not just entertainment. They're memories, fragments of real events that were passed down through generations, distorted by time but rooted in truth. They tell us that the world has been reset before, that civilizations have risen and fallen, and that the survivors carried with them the knowledge of what came before, even if that knowledge was incomplete. The geological record, the ice ages, the volcanic eruptions, the asteroid impacts, the climate shifts, tells us that the Earth is not stable, that catastrophe is not an aberration but a part of the cycle. The world has been reshaped many times, and it will be reshaped again. The question is not whether we'll face catastrophe, but whether we'll be prepared for it, whether we'll have the knowledge and the resilience to survive and rebuild. And the lesson of history, the collapses of the Maya, the Romans, the Bronze Age civilizations, tells us that no civilization is immune, that even the strongest can fall if they ignore the warning signs, if they deplete their resources, if they fail to adapt to changing conditions. We're not special. We're not exempt from the patterns that have brought down every civilization before us. We're just as vulnerable, just as fragile, just as dependent on systems that could fail. But we're also more aware. We have the benefit of hindsight, the ability to look at the past and learn from it. We have the tools to preserve our knowledge, to build resilience into our systems, to plan for the long term. We have the opportunity to break the cycle, to create a civilization that doesn't just rise and fall but endures. The question is whether we'll take that opportunity, whether we'll learn from the past or ignore it, whether we'll preserve our knowledge or let it slip away, whether we'll build a legacy that lasts or become another mystery for future archaeologists to puzzle over. Because the world will go on, with or without us. The Earth will continue its cycles, the ice will advance and retreat, the seas will rise and fall, the continents will drift, and if we fall, if our civilization collapses, then the world will reset once again. The survivors will tell stories about us, myths and legends that blend fact and fiction, that preserve fragments of our knowledge but distort it beyond recognition. And maybe, thousands of years from now, someone will stand among our ruins and wonder who we were and what we knew and why we disappeared. Or maybe we'll endure. Maybe we'll learn from the past, preserve our knowledge, build a civilization that's sustainable and resilient. Maybe we'll be the ones who break the cycle, who prove that humanity can rise without falling, that knowledge can be preserved across millennia, that civilization can last. The choice is ours, the future is unwritten, and the story of civilization is still being told. So as you drift towards sleep tonight, as the world grows quiet and the boundaries between waking and dreaming blur, think about the ruins beneath the waves, the myths whispered around ancient fires, the cycles of ice and fire that have shaped the world. Think about the civilizations that came before, the knowledge they gained and lost, the monuments they built and the mysteries they left behind. And think about us, about the civilization we're building right now, about the knowledge we're accumulating and the risks we're ignoring. Think about what we'll leave behind, what stories future generations will tell about us, what mysteries we'll become, because the world has risen and fallen many times, and it will rise and fall again. The question is not whether the cycle will continue, but whether we'll be part of the rise or part of the fall. Whether we'll be remembered as the civilization that learned from the past, or the civilization that repeated its mistakes. The earth keeps its secrets well, buried beneath the ocean, beneath the soil, beneath the layers of time. But the secrets are there, waiting to be discovered, waiting to be understood. And maybe, just maybe, if we listen closely enough, if we look carefully enough, if we're willing to ask uncomfortable questions and consider impossible possibilities, we'll find the answers we're looking for. Or maybe we'll just find more questions, more mysteries, more reasons to wonder. And maybe that's enough. Maybe the questions are more important than the answers. Maybe the wonder is more valuable than the certainty. Maybe the journey is more meaningful than the destination. Because in the end, the story of civilization is not about where we've been or where we're going. It's about the journey itself, the endless cycle of rise and fall, of knowledge gained and lost, of worlds built and destroyed and built again. It's about the human spirit, the drive to create and explore and understand even in the face of inevitable loss. It's about the monuments we build, the stories we tell, the knowledge we preserve and the legacy we leave behind. And as you close your eyes and let sleep take you, as the world fades and dreams begin, remember this: you are part of that story. You are part of the cycle. You are part of the endless dance of rise and fall, of creation and destruction, of memory and forgetting. And somewhere beneath the waves, beneath the soil, beneath the layers of time, the ruins of forgotten civilizations wait in silence, holding their secrets close, whispering to anyone who will listen that the world is older than we know, stranger than we imagine, and full of mysteries that we've only begun to understand. Sleep well. Dream of ancient cities beneath the sea, of temples carved into mountains, of knowledge written in stone and stars. Dream of the civilizations that came before and the civilizations that will come after. Dream of the cycle, the spiral, the endless turning of the wheel. And when you wake, remember that the past is not dead. It's not even past. It's here, all around us, in the stones and the myths and the questions that won't let us rest. It's in the ruins we discover, and the stories we tell, and the knowledge we preserve. It's in us, and it always will be. Because civilization may restart, but the human spirit endures, and as long as there are people to wonder, to question, to dream, the story will continue. The world will rise again, and again, and again, and maybe, just maybe, one day we'll get it right. But before we can get it right, we need to understand what we've gotten wrong. We need to look at what's been lost, not just in the distant past, but in our own time. We need to see the pattern of forgetting, the way knowledge slips through our fingers like water, no matter how tightly we try to hold on. Because the evidence of lost knowledge isn't just buried in ancient ruins. It's sitting in museums, labelled and catalogued, and we still don't understand it. Take Damascus steel. For centuries, swordsmiths in the Middle East produced blades with a distinctive watery pattern on the surface, blades that were sharper, stronger, and more flexible than anything else in the world. The steel could cut through European swords and armour. It could slice a falling silk scarf in half. The technique was legendary, and the blades were prized across 3 continents, and then, sometime in the 18th century, the knowledge of how to make it disappeared. We have the swords. We can analyse them, study their molecular structure, examine the carbon nanotubes and cementite nanowires that give them their properties. We know what they are, but we don't know exactly how they were made. The precise combination of ore, temperature, technique, and timing was never written down, or if it was, those writings are lost. The knowledge lived in the hands and minds of a master craftsman, passed from teacher to student, and when that chain was broken, the knowledge vanished. We've tried to recreate it. Modern metallurgists have come close, using electron microscopes and computer modelling and techniques that would seem like magic to the original smiths. But it's not quite the same. We're reverse engineering a technology we once possessed and lost. Greek fire is another example. The Byzantine Empire used it for centuries to defend Constantinople, a liquid that burned on water, that couldn't be extinguished by conventional means, that struck terror into enemy fleets. It was the Empire's secret weapon, its formula known only to a select few, guarded more carefully than gold. And then the Empire fell, and the secret died with it. We have descriptions of Greek fire. We know it was deployed through siphons, that it burned green or blue, that water made it burn more fiercely. We have theories, naphtha, quicklime, sulphur, saltpeter, but we don't know. The exact formula was lost when the last person who knew it died without passing it on. Roman concrete is yet another mystery. The Romans built structures that have lasted 2,000 years, concrete that has grown stronger over time, especially the concrete used in harbours and breakwaters, submerged in seawater. The Pantheon's dome, poured in the 2nd century, is still the largest unreinforced concrete dome in the world. Modern concrete crumbles and cracks within decades. Our bridges need constant maintenance. Our buildings have planned obsolescence built into their very foundations. We've only recently begun to understand why Roman concrete was superior. The specific volcanic ash they used, the way seawater reacts with the aluminum-rich minerals to create new binding compounds, but for more than 1,000 years, that knowledge was lost. We forgot how to build things that last. The Antikythera mechanism sits in a museum in Athens, a corroded lump of bronze gears pulled from a shipwreck off the Greek coast. For decades, no one understood what it was. It looked like nothing that should exist in the ancient world. When researchers finally decoded it, they discovered an analog computer of staggering sophistication. It could predict the positions of the sun, moon, and planets. It could calculate eclipses. It had gears within gears, a differential gear system that wouldn't appear again in Western technology for more than 1,000 years. It was built around 100 BCE, and nothing like it appears in the historical record again until the 14th century. One mechanism, one device, found by accident in a shipwreck. How many others were there? How many were lost, melted down for their bronze, corroded beyond recognition, or simply thrown away when no one remembered what they were for? In Iraq, archaeologists have found clay jars from Parthian times, around 200 BCE, that appear to be galvanic cells, ancient batteries. They have copper cylinders, iron rods, and evidence of acidic solutions. They could produce a small electric current. We don't know what they were used for. Electroplating, medical treatment, religious ceremonies? The knowledge is gone, and we're left with artifacts that shouldn't exist, that don't fit our narrative of technological progress. And then there's the stonework, the precision stonework that appears in ancient sites around the world. At Sacsayhuaman in Peru, Massive stones weighing hundreds of tons are fitted together so precisely that you can't slide a piece of paper between them. No mortar, no gaps, just stone against stone, cut and shaped with such accuracy that the joints are nearly invisible. The Inca built this, we're told. The Inca, who didn't have iron tools, who didn't have the wheel, who didn't have written language, they cut and moved and fitted these enormous stones using bronze chisels and stone hammers and sheer human labour. Maybe they did. Maybe the conventional explanation is correct. But when you stand in front of those walls, when you run your hand along those joints, when you see how the stones interlock in 3 dimensions, with complex angles and curves, you start to wonder. You start to ask questions that don't have comfortable answers. The same precision appears at Pumapunku in Bolivia, where andesite blocks are cut with such accuracy that they look machine-tooled, at the Osirian in Egypt, where massive granite blocks are fitted together with the same impossible precision, at Baalbek in Lebanon, where the foundation stones weigh up to 200 tons each. These aren't primitive structures. They're not the work of people just learning to work with stone. They demonstrate a level of technical knowledge and capability that seems out of place, that suggests either techniques we don't understand or a longer history of development than we've acknowledged. What these artifacts and structures tell us is simple and unsettling. Complex technical knowledge can vanish completely. It can disappear within a generation, within a lifetime, sometimes within years. The knowledge of how to make Damascus steel, how to formulate Greek fire, how to mix Roman concrete, all of it was lost, despite being valuable, despite being important, despite being the kind of knowledge that civilizations would want to preserve. If we can lose the formula for concrete in just a few centuries, what else have we lost? What other technologies, what other capabilities, what other understanding has slipped away, leaving us with only the artifacts and the questions? And if we've lost so much in the relatively recent past, in times when writing existed, when records were kept, when there was continuity of culture and institutions, how much more was lost in the deeper past, in the times before writing, in the collapses that left no records at all? The answer is, we don't know. We can't know. The absence of evidence isn't evidence of absence. It's just absence, a blank space where knowledge used to be, a silence where there were once voices. But sometimes the silence is broken by something unexpected. Sometimes we find evidence that suggests the past was stranger than we thought, that knowledge existed in places and times where it shouldn't. That information was preserved through cycles of collapse and renewal in ways we're only beginning to understand. Sometimes we find the maps. In 1929, a group of scholars was cataloguing the contents of the Topkapi Palace Library in Istanbul when they discovered something extraordinary. A map drawn on gazelle skin dated to 1513, signed by an Ottoman admiral named Piri Reis. The map showed the Atlantic Ocean, the coasts of Europe and Africa, and the eastern coast of South America. This wasn't surprising. By 1513, these regions were known to European explorers. Columbus had made his voyages. The Portuguese had sailed around Africa. The age of exploration was well underway. But the map showed something else, something that shouldn't have been there. It showed the coast of Antarctica. Not the ice-covered Antarctica we know today, but the coastline beneath the ice, the mountains and bays and inlets that wouldn't be mapped by modern explorers until the 20th century, using sonar and seismic surveys and technologies that could see through miles of ice. The map showed Antarctica as it would have looked before it was covered by ice, before the glaciers formed, before the continent became the frozen wasteland at the bottom of the world. Piri Reis himself noted on the map that he had compiled it from older sources, from maps drawn in the time of Alexander the Great, from charts used by Columbus, from sources that went back to ancient times. He was copying, not creating. He was preserving information that already existed, information that had been passed down through generations of mapmakers, copied and recopied, preserved through the rise and fall of empires. The conventional explanation is that the map doesn't really show Antarctica. that it's a distortion, a misinterpretation, a coincidence, that the resemblance to the actual coastline beneath the ice is just pareidolia, seeing patterns where none exist. But the resemblance is striking. The proportions are roughly correct, the major features align, and it's not the only map. The Orontius Phineas map of 1531 shows Antarctica as a continent, centred on the South Pole, with rivers and mountains and coastlines. Again, this is Antarctica before the ice, or at least a representation that suggests knowledge of what lay beneath. The Boitier map of 1737 shows Antarctica as two large islands, separated by a channel of water. Modern surveys have confirmed that beneath the ice, Antarctica is indeed two landmasses, connected by a bridge of ice. Without the ice, there would be a channel of water between them, exactly as the map shows. These maps are called portolans, navigational charts used by sailors, and they have a strange quality to them. They're accurate in ways that shouldn't be possible given the technology of their time. They show longitude correctly, something European navigators couldn't calculate accurately until the 18th century. They show coastlines with precision, as if surveyed from the air. And they seem to be copies of copies of copies, each generation of map makers preserving information they didn't fully understand, information that came from sources older than they could trace. Charles Hapgood, a professor of history, spent years studying these maps. He argued that they were evidence of an ancient, advanced civilization that had mapped the world during the last ice age, when sea levels were lower and Antarctica was not yet fully glaciated. He believed that this civilization was destroyed by some catastrophe, but that their maps survived, copied and preserved by later cultures, the information degrading over time but never completely lost. Hapgood's theories are controversial. Most mainstream scholars reject them. They point out the inaccuracies in the maps, the distortions, the ways they don't quite match reality. They argue that the apparent accuracy is exaggerated, that the resemblance to Antarctica is coincidental or misinterpreted. But the maps exist. They're real, physical objects, drawn by real people who claim to be copying from older sources, and they show knowledge that's difficult to explain. How did medieval mapmakers know what Antarctica looked like beneath the ice? How did they know it was there at all? The continent wasn't officially discovered until 1820, and its coastline wasn't fully mapped until the 20th century. The standard answer is that they didn't know, that the maps are wrong or misunderstood, or that we're reading too much into them. But what if the maps are right? What if they're evidence of knowledge that survived from an earlier time, preserved through the Dark Ages and the medieval period, copied by monks and scholars and sailors who didn't understand what they were preserving but knew it was valuable? What if cartographic knowledge, like other forms of knowledge, can survive the collapse of the civilization that created it, passed down through generations, degrading and distorting, but never quite disappearing? Maps are powerful things. They're not just representations of space. They're repositories of knowledge, accumulated over generations, refined through countless voyages and observations. A good map is worth more than gold to a sailor, and map makers guard their sources carefully. If a civilization had mapped the world and that civilization fell, the maps might survive even if everything else was lost. They would be copied, traded, stolen, preserved. The information would degrade, coastlines would shift, proportions would distort, details would be lost. But the core knowledge might persist. And if that's true, if maps can preserve knowledge across millennia, across the rise and fall of civilizations, then what else might have survived? What other information might be hidden in plain sight in documents and artifacts that we've dismissed as myth, or error, or coincidence? The maps whisper a possibility, that the world has been known before, that the continents have been charted, that knowledge of the Earth's geography existed long before we think it did. They suggest that information can survive in unexpected ways, that the past is not as lost as we believe. But they also remind us how fragile that survival is. The maps are copies of copies, each generation introducing new errors, new distortions. The original sources are gone. We don't know who made them, or when, or how. We have only the echoes, the shadows, the traces of knowledge that once existed. And if we can lose the original maps, if we can forget who made them and why, what else have we forgotten? What other knowledge has survived only in fragments, in copies so degraded that we no longer recognize what they represent? The answer might be closer than we think, because we're forgetting things right now, in our own time, in ways that should terrify us. In 1969, humans landed on the moon. It was the culmination of a decade of effort, billions of dollars, the work of thousands of engineers and scientists and technicians. The Saturn V rocket that carried them there was the most powerful machine ever built, a marvel of engineering that stood 363 feet tall and generated 7.6 million pounds of thrust. We can't build it anymore. The blueprints still exist, stored in archives, but they're not enough. The Saturn V wasn't just a design, it was a product of thousands of individual decisions, techniques, and pieces of tacit knowledge that were never written down. The engineers who built it are retired or dead. The companies that manufactured the parts have closed or moved on to other projects. The supply chains have dissolved. The institutional knowledge has evaporated. We could probably recreate something like the Saturn V if we had to, but it would require starting from scratch, relearning techniques, rebuilding supply chains, rediscovering solutions to problems that were solved 50 years ago and then forgotten. This is happening right now in our own civilization with technology that's only decades old. The space shuttle had the same problem. When NASA wanted to restart production of certain components, they discovered that the knowledge of how to make them had been lost. The engineers had retired. The documentation was incomplete. The institutional memory was gone, or consider software. There are programming languages from the 1960s and 70s that are still running critical systems, banking systems, government databases, infrastructure controls, but almost no one knows how to program in them anymore. COBOL, Fortran, assembly languages specific to long obsolete hardware. The people who wrote the original code are retiring, and there aren't enough young programmers learning these languages to replace them. When something breaks, when a bug needs to be fixed, when a system needs to be updated, organizations scramble to find someone, anyone, who still remembers how these systems work. They pay enormous salaries to consultants who are pulled out of retirement because they're the last people alive who understand the code, and when those people die, the knowledge dies with them. We have the source code, in many cases. We have the documentation, but code isn't self-explanatory. It's full of assumptions, shortcuts, workarounds for problems that no one remembers. Reading old code is like reading a foreign language where you know the words but not the grammar, where the context has been lost and the meaning is obscure. Data formats are another vulnerability. We have files from the 1980s and 90s that we can no longer open because the software that created them no longer exists, and the format specifications were never properly documented. We have data stored on media that's degrading, floppy disks, magnetic tapes, optical disks, and no working drives to read them. The BBC Domesday Project, created in 1986 to commemorate the 900th anniversary of the original Domesday Book, stored a comprehensive survey of Britain on special laser discs. Within 15 years, the discs were unreadable. The hardware had become obsolete. The software no longer ran on modern computers. A project designed to last 1,000 years became inaccessible in less than 2 decades. Meanwhile, the original Domesday Book, written on vellum in 1086, is still perfectly readable. We're creating vast amounts of information, more than any previous civilization, but we're storing it in formats that are incredibly fragile. Digital storage seems permanent, but it's not. Hard drives fail, servers crash, file formats become obsolete. Companies go out of business, taking their proprietary formats with them. And even when the data survives, the context often doesn't. We have databases full of information, but without the documentation, Without the understanding of what the fields mean and how they relate to each other, the data is meaningless. It's just numbers and text, disconnected from the knowledge that gave it meaning. This is happening now, not in the distant past, not in some hypothetical future, but right now in the most advanced, most technologically sophisticated civilization that has ever existed. We're forgetting how to build rockets. We're losing programming languages. We're creating data we can't read. And this is with all our technology, all our documentation, all our institutional structures designed to preserve knowledge. Imagine what happens when those structures fail. Imagine what happens when the power goes out, when the servers go dark, when the internet fragments and dies. How much of our knowledge exists only in digital form? How much of it could we recover if we lost access to computers? The answer is not much. We've become dependent on technology to store and retrieve information, and that dependency is a vulnerability. We've externalized our memory, offloaded it onto machines, and in doing so, we've made ourselves fragile. A medieval monk could copy a manuscript by hand, preserving it for future generations. We can't copy our hard drives by hand. We can't recreate our databases from memory. We can't rebuild our software without computers to run it on. We've created a civilization that's more advanced than any that came before, but also more fragile. We've built a tower of knowledge that reaches higher than ever, but the foundation is crumbling, and we're not sure how to fix it. And if we're losing knowledge this quickly, this easily, in a time of peace and prosperity and technological abundance, what happens when things get difficult? What happens when resources become scarce, when institutions fail, when the systems we depend on start to break down? The answer is written in history, in the collapses that came before, in the knowledge that was lost and the darkness that followed. But to understand that answer, we need to understand what makes knowledge vulnerable in the first place. We need to see the mechanisms of forgetting, the ways that information slips away, the reasons why even the most important knowledge can vanish within a generation. Knowledge is not a thing. It's not a physical object that you can hold in your hand, that exists independently of the people who possess it. Knowledge is a relationship, a connection between minds, a pattern of information that exists only as long as it's maintained. And that makes it fragile. The most basic form of knowledge is experiential. The things you learn by doing, the skills you develop through practice, the understanding that comes from direct engagement with the world. This is the knowledge of the craftsman, the farmer, the hunter. It's embodied knowledge, stored in muscle memory and intuition, passed down through demonstration and apprenticeship. This kind of knowledge is robust in some ways. It doesn't require writing or technology. It can survive without institutions or formal education. As long as there are people practicing the skill, the knowledge persists. But it's also vulnerable. If the practice stops, if the chain of transmission is broken, the knowledge disappears. You can't learn to forge a sword by reading about it. You can't learn to navigate by the stars from a textbook. You need someone to show you, to guide you, to correct your mistakes. You need years of practice, of trial and error, of developing the intuition that separates a master from a novice. And if there's no one to teach you, if the masters are dead and the apprentices were never trained, the knowledge is gone. You're starting from scratch, rediscovering techniques that were once common, relearning lessons that were once obvious. This is what happened with Damascus steel, with Greek fire, with countless other technologies. The knowledge lived in the hands and minds of practitioners, and when those practitioners died without passing it on, the knowledge died with them. Written knowledge is more durable, in theory. You can write something down and it can survive for centuries, for millennia, independent of any individual person. The written word is humanity's greatest tool for preserving information across time. But writing has its own vulnerabilities. First, it requires literacy. If people can't read, if the language is forgotten, if the script becomes obsolete, the writing becomes meaningless. We have texts in Linear A, the script of the Minoan civilization, and we can't read them. We have the Voynich manuscript, written in an unknown script or code, and despite centuries of effort, no one has deciphered it. The information is there, physically present, but inaccessible. Second, writing requires physical media, and physical media degrades. Paper burns, rots, crumbles. Parchment and vellum last longer, but they're expensive and can still be destroyed. Stone inscriptions endure, but they're limited in what they can convey. You can't carve a technical manual into stone. Third, writing requires copying. A single manuscript is vulnerable to fire, flood, war, accident. To preserve knowledge, you need multiple copies, distributed across space and time. But copying introduces errors. Each generation of scribes makes mistakes, misreads words, introduces their own interpretations. Over time, the text drifts, and the original meaning can be lost. And fourth, writing requires context. A text without context is just words on a page. You need to understand the language, the culture, the assumptions that the author took for granted. You need to know what the words meant to the people who wrote them, not just what they mean to you. This is why so much ancient knowledge is lost even when the texts survive. We have Greek and Roman writings on technology, on engineering, on medicine. But the texts are often vague, assuming knowledge that the reader already possesses. They describe processes without explaining the details, because the details were common knowledge at the time. They use terms that we can't translate with certainty, because we don't know exactly what they referred to. The texts are there, but the knowledge is gone, locked away behind a barrier of lost context. And then there's specialized knowledge, the kind that requires years of education, that builds on layers of prior understanding, that exists only in the minds of experts. This is the knowledge of the scientist, the engineer, the scholar. It's the most advanced knowledge we have, the cutting edge of human understanding. It's also the most fragile. Specialized knowledge requires infrastructure. It requires schools and universities, teachers and students, books and laboratories. It requires a society wealthy enough to support people who don't produce food or goods, who spend their time thinking and researching and teaching. If that infrastructure fails, if the universities close, if the books are burned, if the experts die without training successors, the knowledge vanishes. Not slowly, not gradually, but quickly, within a generation or two. This is what happened in the collapse of the Western Roman Empire. The knowledge didn't disappear all at once, but it faded rapidly. The schools closed, the libraries were destroyed or abandoned, the experts died, and there was no one to replace them. Within a few generations, knowledge that had been common among the educated elite, geometry, engineering, medicine, philosophy, became rare, preserved only in a few monasteries, in fragments and summaries that captured only a shadow of the original understanding. It took centuries to recover that knowledge, and much of it was only recovered because it had been preserved in the Islamic world, where the infrastructure of learning had survived. But the Islamic world had its own collapses, its own periods of decline, and knowledge was lost there too. The House of Wisdom in Baghdad, one of the greatest centres of learning in the medieval world, was destroyed by the Mongols in 1258. The books were thrown into the Tigris River, so many that the water ran black with ink. Scholars were killed. The institutional memory was shattered. Some knowledge survived, preserved in other cities, in other libraries. But some was lost forever, and we'll never know what it was. This is the pattern. Knowledge accumulates slowly over generations, each scholar building on the work of those who came before. But it can be lost quickly, in a single catastrophe, in a single generation of neglect. And the more specialized the knowledge, the more dependent it is on infrastructure, the more vulnerable it becomes. Our civilization has the most specialized knowledge in history. We have experts who spend their entire lives studying narrow fields, who understand things that no one else understands, who possess knowledge that exists nowhere else. We have technologies that require global supply chains, that depend on components manufactured in a dozen different countries that can't be produced by any single nation or company. This specialization has given us incredible capabilities. It's allowed us to split the atom, to sequence the genome, to send probes to the edge of the solar system, but it's also made us fragile. If the supply chains break, if the experts die, if the infrastructure fails, we lose not just the technology, but the knowledge of how to create it. We're building a tower of knowledge that reaches higher than ever before, but the foundation is narrow and the structure is unstable. We're creating dependencies that we don't fully understand, vulnerabilities that we're only beginning to recognize. And we're doing it with the assumption that the future will be like the present, that the systems we depend on will continue to function, that the knowledge we're creating will be preserved. But history suggests otherwise. History suggests that continuity is the exception, not the rule, that collapse is always a possibility, that the knowledge we take for granted can vanish faster than we imagine, and if we're not careful, if we don't take steps to preserve what we know, to make our knowledge more robust, to create redundancies and backups and systems that can survive disruption, we might find ourselves in the same position as the survivors of past collapses, staring at the ruins of a civilization we can no longer understand, trying to piece together knowledge that was lost when the world fell apart. But maybe the knowledge was never completely lost. Maybe it survived, in fragments, in ways we don't recognize. Maybe the ruins themselves are evidence of something we've been reluctant to acknowledge. Because when you look at the precision of ancient stonework, when you examine the astronomical alignments of megalithic sites, when you study the mathematical knowledge encoded in myths and monuments, you start to see patterns that don't fit comfortably into the standard narrative of human development. You start to see evidence that suggests the past was more sophisticated than we've been taught. The precision of the stonework at sites like Pumapunku, Sacsayhuaman, and the Osirion is difficult to explain with the tools we believe were available. Bronze chisels and stone hammers can shape stone, but they can't create the kind of precision we see in these structures. They can't cut perfectly flat surfaces, can't create right angles accurate to within fractions of a degree, can't drill holes that are perfectly circular and parallel. Modern stonemasons, using steel tools and power equipment, struggle to match the precision of ancient work. Some have tried, using only the tools that would have been available to ancient builders, and they can't do it. They can create something that looks similar from a distance, but up close, the differences are obvious. The ancient work is better, so how did they do it? The conventional answer is that they had techniques we don't understand, that they were more skilled than we give them credit for, that they spent enormous amounts of time and labour to achieve precision through patience and persistence. Maybe that's true. Maybe the ancient builders were simply better craftsmen than we are, more patient, more skilled, more dedicated. But there's another possibility, one that's less comfortable, that they had knowledge we've lost, that they had techniques, tools, or understanding that didn't survive into the historical period, that the precision we see is evidence of a technological capability that existed and then vanished. This isn't as far-fetched as it sounds. We know that knowledge can be lost. We've seen it happen with Damascus steel, with Roman concrete, with countless other technologies. Why couldn't it happen with stoneworking techniques? And if it did happen, if there were advanced stoneworking techniques that were lost, what else might have been lost with them? The astronomical alignments of ancient sites suggest another kind of knowledge that seems out of place. The Great Pyramid of Giza is aligned to true north with an accuracy of 3/60th of a degree. Stonehenge marks the solstices and equinoxes. The temples of Angkor Wat in Cambodia are aligned to the spring equinox. Sites around the world, built by cultures that supposedly had no contact with each other, show the same concern with astronomical alignments, the same knowledge of the movements of the sun, moon, and stars. This knowledge requires long-term observation, mathematical understanding, and the ability to predict celestial events. It requires a level of astronomical sophistication that we don't usually associate with ancient cultures. But the evidence is there. carved in stone, built into the very structure of these monuments. And then there's the precession of the equinoxes, the slow wobble of the Earth's axis that causes the position of the stars to shift over thousands of years. It takes 26,000 years for the cycle to complete, and detecting it requires observations spanning centuries, comparing the position of stars across generations. The ancient Greeks knew about precession. Hipparchus described it in the 2nd century BCE. But there's evidence that the knowledge is older, much older. The Sphinx at Giza faces due east, toward the rising sun on the equinox. But some researchers have argued that it was originally built to face the constellation Leo, which would have risen in the east at the spring equinox around 10,500 BCE, during the age of Leo in the precessional cycle. If that's true, if the Sphinx is that old, it predates Egyptian civilization by thousands of years. It would be evidence of a culture that understood precession, that built monuments aligned to the stars, that had astronomical knowledge we don't usually associate with the Stone Age. This is controversial, to put it mildly. Most Egyptologists reject the idea, pointing to evidence that the Sphinx was built during the Old Kingdom, around 2500 BCE. They argue that the geological evidence for an older date is misinterpreted, that the astronomical alignments are coincidental or retrofitted. But the debate continues because the evidence is ambiguous and the implications are profound. If the Sphinx is older than we think, if it was built by a culture that predates the Egyptians, then who built it? Where did they come from? What happened to them? The same questions apply to other sites. Gobekli Tepe, built 11,000 years ago, shows a level of organisation and capability that shouldn't exist in a society of hunter-gatherers. The site required planning, coordination, specialised labour. It required a social structure complex enough to mobilise hundreds of people for a project that had no immediate practical benefit, and it's not alone. Across the world, there are megalithic sites that date to the end of the last ice age or shortly after. Dolmens, stone circles, massive earthworks. They're found in Europe, Asia, Africa, the Americas. Different cultures, different continents, but the same impulse to build in stone, to create monuments that would endure. Why? What were they trying to preserve? What knowledge were they encoding in these structures? Some researchers have argued that these sites are evidence of a global megalithic culture, a civilization that existed before the Ice Age ended, that was destroyed by the cataclysms of the Younger Dryas, and that left behind only these monuments as evidence of its existence. This is speculative, and most archaeologists reject it. They argue that the similarities between megalithic sites are due to convergent evolution, that different cultures independently developed the same techniques and the same desire to build in stone. But the similarities are striking. The precision of the stonework, the astronomical alignments, the sheer scale of the projects, the fact that they appear around the world in cultures that supposedly had no contact with each other. And then there are the myths, the stories of a golden age, of a time before the flood, of gods who came from the sea and taught humanity the arts of civilization. These myths are found in cultures around the world, and they're remarkably consistent. They speak of a time when knowledge was greater, when the world was different, when there were people who knew things that were later forgotten. Are these myths just stories, invented to explain the world, to give meaning to the past? Or are they memories, distorted by time and retelling, but rooted in real events, real people, real knowledge? We don't know. We can't know, not with certainty. The evidence is fragmentary, ambiguous, open to interpretation. But the possibility is there, whispered in the stones and the stars and the stories. The possibility that civilization is older than we think, that knowledge has been lost and recovered multiple times, that the cycle of rise and fall has been turning for longer than we've acknowledged. And if that's true, if there were civilizations before ours that rose and fell and left only fragments behind, then we need to ask, what did they know? What did they preserve? And what can we learn from their failure? Because failure is what happens when knowledge is lost. Failure is what happens when the systems that preserve information break down, when the chain of transmission is severed, when the people who know things die without passing them on. And failure happens fast. When a civilization collapses, when the infrastructure fails, when the institutions crumble, people don't have time to preserve knowledge. They're too busy surviving. Food becomes the priority. Shelter, safety. The immediate needs of staying alive overwhelm everything else. Libraries are abandoned, schools close, books are burned for warmth. The experts, the scholars, the people who possess specialized knowledge, they're no more valuable than anyone else when everyone is starving. And within a generation, the knowledge is gone. The survivors of the collapse might remember that there were books, that there were people who knew things, that there was a time when life was different, but they don't remember the details. They don't remember how things worked, how they were made, how the systems functioned. Their children remember even less. They grow up in a world where the old civilization is just a memory, a story told by their parents, a collection of ruins that no one understands. They know that things were different once, but they don't know how or why. And their children, the third generation, grow up in a world where the old civilization is myth. It's a story about the past, about a golden age that may or may not have existed, about gods or heroes or ancestors who could do things that no one can do anymore. 3 generations. That's all it takes for knowledge to become myth, for history to become legend, for understanding to become mystery. We've seen this happen over and over in historical collapses. When the Western Roman Empire fell, the knowledge didn't disappear immediately. There were still schools in the 6th century, still scholars who could read Latin and Greek, still people who understood engineering and mathematics and medicine. But by the 8th century, most of that knowledge was gone. Literacy rates had plummeted. The schools had closed. The books had been lost or destroyed. The people who remained could see the ruins of Roman civilization, the aqueducts, the roads, the buildings, but they didn't know how they were built. They didn't have the knowledge to maintain them, let alone to create new ones. The ruins became mysterious, attributed to giants or gods or magic. The knowledge became legend. It took centuries to recover, and much of it was only recovered because it had been preserved elsewhere, in the Byzantine Empire and the Islamic world, where the collapse had been less severe. The same pattern appears in other collapses. The Maya civilization collapsed around 900 CE, and within a few generations the great cities were abandoned, swallowed by the jungle. The people who remained didn't know who had built them. They didn't know how to read the inscriptions. The knowledge was lost and the cities became ruins, mysterious and inexplicable. When the Spanish arrived in the 16th century, they found the descendants of the Maya living in small villages, with no memory of the great civilization that had existed just a few centuries before. The knowledge of how to build the pyramids, how to create the elaborate calendar systems, how to write in hieroglyphs, all of it was gone. The Bronze Age collapse around 1200 BCE is another example. Within a few decades, the great civilizations of the Eastern Mediterranean, the Hittites, the Mycenaeans, the Egyptians, collapsed or were severely weakened. Trade networks broke down, cities were abandoned, writing disappeared in some regions, and the knowledge was lost. The techniques of bronze working, the systems of administration, the diplomatic protocols, all of it vanished. The people who survived had to start over, rebuilding from the ruins, rediscovering techniques that had once been common. This is the pattern. When collapse comes, survival takes priority over preservation. The immediate needs of food, shelter, and safety overwhelm the long-term goal of maintaining knowledge. And once the knowledge is lost, it's almost impossible to recover without outside help. The survivors might try to preserve what they can. They might write things down, create caches of books or tools, try to pass on what they know to their children. But writing requires literacy, and literacy requires education, and education requires resources that survivors don't have. Tools require maintenance and materials that might not be available, and children who are struggling to survive don't have time to learn things that don't have immediate practical value. So the knowledge fades, the books rot or are lost. The tools break and can't be replaced. The children learn only what they need to survive, and the rest is forgotten. Within a generation, the specialized knowledge is gone. Within 2 generations, the literacy is gone. Within 3 generations, the memory of what was lost is gone, and the cycle begins again from a lower starting point, with less knowledge, less capability, less understanding. This is what makes collapse so devastating. It's not just the immediate destruction, the death and suffering and chaos. It's the loss of knowledge, the erasure of centuries or millennia of accumulated understanding, the resetting of the clock to an earlier stage of development, and it's why we need to think carefully about what we're preserving and how. Because if collapse comes, and history suggests that it will eventually, the knowledge we've accumulated will be lost unless we take deliberate steps to protect it. But protecting knowledge across a collapse is harder than it sounds. Much harder. We live in a world that runs on electricity. Everything we do, everything we depend on requires power. Our lights, our heating, our refrigeration, our computers, our phones, our internet, our factories, our hospitals, our transportation systems. Take away the electricity, and modern civilization stops functioning within hours. The food in your refrigerator spoils, the gas pumps don't work so you can't refuel your car, the water treatment plants shut down so clean water stops flowing, the hospitals lose power and people on life support die. The communication networks fail and you can't call for help. Within days, the grocery stores are empty. Within weeks, people are starving. Within months, the death toll is in the millions. This isn't speculation. This is what happens in major disasters, in wars, in situations where the power grid fails for extended periods. We've seen it happen on small scales, in limited regions. We know what the consequences are. Now imagine it happening everywhere, all at once, with no prospect of recovery. This is the nightmare scenario, the collapse that keeps experts awake at night. A solar flare that fries the transformers, a cyber attack that takes down the grid, an electromagnetic pulse from a nuclear weapon detonated in the atmosphere, a cascading failure that spreads from one region to another, taking down the entire interconnected system. It's possible. It's not even that unlikely. The power grid is fragile, held together by aging infrastructure, vulnerable to disruptions, dependent on components that take months or years to manufacture and can't be quickly replaced. And if it fails, if the power goes out and stays out, we lose everything that depends on electricity, which is to say we lose everything. Our knowledge is stored on computers, on servers, on hard drives that require power to access. Our communication systems require power. Our manufacturing systems require power. Our ability to coordinate, to organize, to respond to the crisis, all of it requires power. Without electricity, we're back to the 19th century, but without the infrastructure or knowledge that people in the 19th century had. We don't know how to live without power. We don't know how to grow food without industrial agriculture. We don't know how to manufacture goods without factories. We don't know how to communicate without phones and internet. We've become dependent on systems that are incredibly powerful, but also incredibly fragile. We've built a civilization that works beautifully as long as everything functions, but that collapses catastrophically when any critical component fails. And it's not just electricity, it's the global supply chains that deliver food, medicine, and goods. It's the just-in-time manufacturing systems that keep no inventory, that depend on constant deliveries of components from around the world. It's the financial systems that exist only as numbers in computers that can vanish in a crash or a cyber attack. We've optimized for efficiency, for cost reduction, for maximum performance under ideal conditions, but in doing so, we've eliminated redundancy, eliminated buffers, eliminated the slack that allows systems to survive disruptions. A single point of failure can cascade through the entire system. A factory in one country stops producing a critical component, and factories around the world shut down. A port closes and supply chains collapse. A bank fails and the financial system freezes. We've created a tightly coupled, highly optimized, incredibly fragile system, and we're betting our civilization on the assumption that nothing will go seriously wrong. But things go wrong. They always do. History is full of disruptions, disasters, catastrophes that no one predicted, and when they happen, when the systems we depend on fail, we discover just how vulnerable we are. The COVID-19 pandemic was a small taste of this. A relatively mild disruption, a disease that killed a small percentage of those infected, was enough to shut down economies, disrupt supply chains, and reveal the fragility of systems we thought were robust. And that was with the power still on, with the internet still functioning, with governments still able to coordinate responses. Imagine what happens when the disruption is more severe, when the infrastructure itself fails, when there's no one to coordinate a response because the systems of coordination have collapsed. The survivors would face a world that's hostile and unforgiving. They would need to find food, water, shelter. They would need to protect themselves from violence, from disease, from the elements. They would need to rebuild, to create new systems, to rediscover knowledge that was lost. And they would need to do all of this without the tools and resources that we take for granted, without electricity, without computers, without the accumulated knowledge of centuries stored in formats they can't access. What would they preserve? What knowledge would they prioritize? The answer is the knowledge that keeps them alive. Agriculture, medicine, basic crafts, the practical skills that have immediate survival value. Everything else would be lost. The science, the mathematics, the philosophy, the art, all of it would be abandoned because it doesn't help you survive. It doesn't feed you or heal you or keep you warm. And within a generation, it would be forgotten. The survivors would tell their children about the old world, about the marvels that existed, about the knowledge that was lost. But the children wouldn't understand. They would grow up in a world where survival is the only priority, where there's no time or resources for anything else. And their children would grow up in a world where the old civilization is just a myth, a story about a time when people could do impossible things, when there were machines that thought and flew and connected the world. 3 generations, that's all it takes. And the cycle would begin again from the bottom, with the survivors trying to rebuild, trying to rediscover, trying to piece together knowledge from fragments and memories and ruins. Unless we do something to prevent it. Unless we take steps now to preserve knowledge in ways that can survive a collapse, to create systems that are more robust, to build redundancy and resilience into our civilization. But that requires acknowledging the possibility of collapse, and we're not good at that. We prefer to believe that the future will be like the present, that progress is inevitable, that the systems we've built will endure. History suggests otherwise. In the 1980s, the United States government faced an unusual problem. They were building repositories for nuclear waste, materials that would remain dangerously radioactive for tens of thousands of years, and they needed to warn future generations about the danger. How do you communicate across 10,000 years? How do you create a warning that will still be understood when languages have changed, when civilizations have risen and fallen, when everything about the world is different? You can't use words. Languages change too quickly. English is only about 1,500 years old, and Old English is barely recognizable to modern speakers. Go back 10,000 years, and there's no continuity at all. You can't rely on cultural symbols. The meanings of symbols change. What seems obvious to us might be meaningless or misleading to future people. A skull and crossbones means danger to us, but to someone in the future, it might mean medicine or pirates or nothing at all. You can't assume that future people will have the same technology, the same knowledge, the same context. They might not be able to read. They might not understand radiation. They might not even know what nuclear waste is. So how do you warn them? The government assembled a team of experts, linguists, anthropologists, archaeologists, artists, to study the problem. They called it the Human Interference Task Force, and they spent years trying to design a warning system that could last 10,000 years. They considered many options: massive earthworks that would be visible from space, monuments covered in warnings in multiple languages, landscapes designed to evoke dread and unease, to make people want to stay away without understanding why. They proposed creating an atomic priesthood, a group that would pass down knowledge of the danger through generations, maintaining the warning through oral tradition and ritual. They suggested breeding cats that would change colour in the presence of radiation, and creating myths about the danger of the glowing cats, so that future people would know to stay away. Some of these ideas were implemented. The waste isolation pilot plant in New Mexico has a marker system designed to last 10,000 years. It includes massive granite monuments, earthworks, and warnings in 7 languages, including Navajo and Spanish, as well as pictograms that attempt to convey danger without words. But no one knows if it will work. No one knows if future people will understand the warnings, or if they'll ignore them, or if they'll interpret them in ways we can't predict. The problem of communicating across deep time is nearly impossible. We can't know what future people will be like, what they'll understand, what they'll value. We can't predict how languages will change, how cultures will evolve, how knowledge will be lost and rediscovered. All we can do is try, and hope that something survives, that some fragment of the warning makes it through, that future people will be able to piece together enough information to understand the danger. This is the challenge of preserving knowledge across collapse. It's not just about storing information, it's about ensuring that the information can be understood, that it has context, that it's accessible to people who might have very different knowledge and capabilities than we do. Books can be lost or destroyed. Digital storage can fail. Languages can change. Entire civilizations can fall, taking their knowledge with them. So what do we preserve? How do we preserve it? And how do we ensure that it survives not just decades or centuries, but millennia? There's no easy answer. Every method has vulnerabilities. Every system can fail. But there are things we can do. We can create redundancy, storing knowledge in multiple formats, in multiple locations. We can use durable media, stone, metal, materials that will last for thousands of years. We can encode information in ways that are self-explanatory, that don't require specialized knowledge to understand. We can create time capsules, repositories of knowledge designed to survive collapse. We can bury them, hide them, protect them from the elements and from human interference. We can teach people the importance of preservation, the value of knowledge, the need to pass information down through generations. We can create cultures that prioritize memory, that honor the past, that see themselves as links in a chain that stretches from the distant past to the distant future. But ultimately, we can't control what survives. We can't guarantee that our knowledge will endure. All we can do is try, and hope that something makes it through, that some fragment of what we know survives to help future generations. And maybe that's enough. Maybe the fragments are all that's needed. Maybe future people will be able to piece together enough from the ruins, from the artifacts, from the stories to rebuild, to rediscover, to continue the journey. Or maybe they won't. Maybe the knowledge will be lost and they'll have to start over from the beginning, rediscovering everything we've learned, making the same mistakes, facing the same challenges. We don't know. We can't know. But we can ask ourselves, what would we preserve? If we knew collapse was coming, if we had time to prepare, what knowledge would we write down? What skills would we teach? What information would we consider essential? Think about it. Really think about it. You have a year, maybe less. You know that civilization is going to collapse, that the power will go out and stay out, that the systems we depend on will fail. You know that you and the people around you will need to survive without technology, without infrastructure, without the accumulated knowledge of centuries. What do you preserve? You can't save everything. You don't have time and you don't have space. You need to prioritize. You need to decide what's essential, what's valuable, what's worth the effort to preserve. Do you preserve science, the laws of physics, the principles of chemistry, the understanding of biology? These are the foundations of our technological civilization, the knowledge that allowed us to build everything we have. But they're abstract. They're not immediately useful. Knowing that FEMA doesn't help you grow food, understanding evolution doesn't help you purify water. The science is important, but it's not survival knowledge. Do you preserve technology? The designs for machines, the techniques for manufacturing, the knowledge of how to build the tools that build the tools. This is practical knowledge. Knowledge that could help survivors rebuild faster, that could preserve some of the capabilities we've developed. But technology requires infrastructure. You can't build a computer without factories, without supply chains, without electricity. You can't manufacture steel without mines, without furnaces, without fuel. The knowledge is useless without the systems to implement it. Do you preserve medicine? The understanding of disease, the techniques for surgery, the formulas for antibiotics. This is knowledge that saves lives, that reduces suffering, that has immediate practical value. But medicine requires materials. You need drugs, equipment, sterile environments. You need training and practice. And you need a society stable enough to support doctors, to allow people to specialize in healing rather than just surviving. Do you preserve agriculture? The knowledge of how to grow food, how to breed plants and animals, how to manage soil and water. This is survival knowledge, the foundation of civilization, the skill that allows people to settle down and build communities. This is essential. This is what you preserve first. The knowledge of how to feed people, how to create a surplus, how to support a population large enough to specialize and develop other skills. But even agriculture requires knowledge that we've forgotten. Modern farming depends on machinery, on fertilizers, on pesticides, on hybrid seeds. Without these, yields drop dramatically. You need to know how to farm the old way, with hand tools, with natural fertilizers, with techniques that don't require industrial inputs. Do you know how to do that? Do you know how to grow food without a tractor, without chemical fertilizers, without buying seeds from a store? Most people don't. We've outsourced that knowledge to specialists, to farmers who make up a tiny percentage of the population. And even they depend on systems that wouldn't survive a collapse. So you'd need to preserve not just the knowledge of agriculture, but the practical skills, the hands-on experience, the understanding that comes from actually doing it. And that's hard to write down. That's the kind of knowledge that requires demonstration, practice, apprenticeship. Do you preserve history? The story of what happened, the record of our civilization, the lessons we've learned? This is knowledge that doesn't have immediate survival value, but it has long-term value. It helps future generations understand where they came from, what mistakes to avoid, what possibilities exist. But history requires literacy, and literacy requires education, and education requires resources. In the immediate aftermath of collapse, no one has time to teach children to read. They're too busy surviving, so the history would be lost unless you preserve it in a form that doesn't require literacy. Oral tradition maybe. Stories passed down through generations. But oral tradition is fragile, subject to distortion, vulnerable to being forgotten. Do you preserve art? Music, literature, philosophy? The things that make life worth living, that give meaning and beauty to existence. These are not survival skills, but they're part of what makes us human. But they're luxuries. In a world where everyone is struggling to survive, where food is scarce and life is hard, there's no time for art. There's no energy for philosophy. The immediate needs overwhelm everything else. And so the art would be lost, the music forgotten, the literature abandoned. The survivors would focus on survival, and everything else would fade away. This is the tragedy of collapse. It's not just the loss of technology or infrastructure. It's the loss of everything that makes civilization worthwhile. The knowledge, the culture, the art, the accumulated wisdom of generations. All of it vanishes because survival takes priority over everything else. So what do you preserve? The answer is, you preserve what you can. You write down the essentials, agriculture, medicine, basic crafts. You teach your children the skills they'll need to survive. You tell them stories about the world that was, about the knowledge that existed, about the importance of remembering, and you hope that something survives, that some fragment of what you preserve makes it through, that future generations will be able to build on it, to rediscover what was lost, to continue the journey. But you can't guarantee it. You can't control what survives. All you can do is try. And maybe that's the lesson. Maybe that's what the ruins and the myths and the lost knowledge are trying to tell us. That preservation is hard. That knowledge is fragile. That civilization is not inevitable, not permanent, not guaranteed. That we need to be intentional about what we preserve, about how we preserve it, about why it matters. Because if we're not careful, if we don't take steps to protect what we know, we might find ourselves in the same position as the survivors of past collapses, staring at ruins we can't understand, trying to piece together knowledge from fragments, starting over from the beginning. And the cycle will continue, the wheel will turn, and future generations will look at our ruins and wonder who we were, what we knew, and why we disappeared. So here we are, at the end of this journey, this exploration of lost civilizations and forgotten knowledge, of cycles and collapses and the fragility of everything we've built. What have we learned? We've learned that the past is stranger than we thought, that there are ruins and artifacts that don't fit comfortably into our narrative of progress, that suggest knowledge existed in places and times where it shouldn't. We've learned that knowledge can be lost completely and utterly, even knowledge that seems essential, even in civilizations that have writing, and institutions and systems designed to preserve information. We've learnt that we're losing knowledge right now, in our own time, that the most advanced civilization in history is forgetting how to build rockets, losing programming languages, creating data it can't read. We've learned that collapse is not a distant possibility but a recurring pattern, that civilizations rise and fall, that the systems we depend on are more fragile than we like to believe. We've learned that when collapse comes, survival takes priority over preservation, that knowledge is abandoned in favour of immediate needs, that within a few generations understanding becomes myth and history becomes legend. We've learned that our civilization is vulnerable in ways we don't fully appreciate, that our dependence on electricity and computers and global supply chains has made us powerful but also fragile, that a single disruption could cascade through the entire system. We've learned that communicating across deep time is nearly impossible, that preserving knowledge for future generations requires more than just writing it down, that context and understanding can be lost even when the information survives. And we've learned that the question of what to preserve is deeply personal, that it forces us to confront what we value, what we consider essential, what we want to pass on to the future. But we've also learned something else, something more hopeful. We've learned that knowledge can survive in fragments, in unexpected ways, that maps can preserve information across millennia, that myths can encode real events, that ruins can whisper secrets to those willing to listen. We've learned that humans are resilient, that we've survived collapses before, that we've rebuilt and rediscovered and continued the journey even after everything seemed lost. We've learned that the cycle of rise and fall is not just a story of loss, but also a story of renewal, that each civilization builds on the ruins of those that came before, that knowledge accumulates even as it's lost, that progress is possible even if it's not inevitable. And we've learned that we have a choice. We can ignore the lessons of history, assume that our civilization is different, that we're immune to the forces that brought down every civilization before us. We can continue on our current path, optimizing for efficiency, eliminating redundancy, building systems that are powerful but fragile. Or we can learn from the past. We can acknowledge our vulnerability. We can take steps to preserve knowledge, to build resilience, to create systems that can survive disruption. We can be intentional about what we're building, about what we're preserving, about what we want to leave behind. We can't prevent collapse entirely. The Earth has its rhythms and we're subject to forces beyond our control. Asteroids will strike. Volcanoes will erupt, climate will change, civilizations will rise and fall, but we can influence how we fall and what survives. We can choose to preserve knowledge in durable forms, to teach skills that don't depend on technology, to create cultures that value memory and continuity. We can choose to build systems that are robust rather than just efficient, that have redundancy and slack and the ability to survive disruption. We can choose to be good ancestors, to think about the people who will come after us, to leave them something more than ruins and mysteries. Because in the end, that's what this is about. Not just understanding the past, but shaping the future. Not just recognizing the cycle, but trying to break it, or at least to make it less destructive. The world has risen and fallen many times before. Civilizations have come and gone, leaving behind only fragments and questions. Knowledge has been lost and rediscovered, forgotten and remembered, preserved in unexpected ways. And it will happen again. The cycle will continue. The wheel will turn. But maybe, just maybe, we can make it different this time. Maybe we can preserve more, lose less, leave behind something that will help future generations avoid our mistakes and build on our successes. Maybe we can be the civilization that finally gets it right, that creates something sustainable and resilient and designed to last. Or maybe we'll fail, like all the others. Maybe our ruins will join the others, beneath the waves and the soil and the layers of time. Maybe future archaeologists will puzzle over our artifacts, wondering who we were and what we knew and why we disappeared. But even if we fail, even if our civilization falls and our knowledge is lost, the human spirit will endure. People will survive. They'll rebuild. They'll rediscover. They'll continue the journey, climbing out of the ruins, reaching for the stars, asking the same questions we've asked, dreaming the same dreams. Because that's what we do. That's what makes us human. We build. We learn. We create. We preserve. We tell stories and pass down knowledge and try to make sense of the world. We look at the ruins of the past and wonder. We look at the possibilities of the future and hope. And somewhere in that wondering and hoping, in that endless cycle of creation and destruction, of memory and forgetting, we find meaning. We find purpose. We find the reason to continue, even knowing that everything we build will eventually fall. Because the journey is what matters. The struggle to understand, to preserve, to create something that will outlast us. The attempt to leave the world a little better than we found it, to pass on knowledge to the next generation, to be a link in the chain that stretches from the distant past to the distant future. That's the story of civilization. Not a straight line of progress, but a spiral, a cycle, a wheel that turns and turns. Rising and falling, building and collapsing, remembering and forgetting. And we're part of that story. We're living it right now, in this moment, in this civilization that's more advanced and more fragile than any that came before. What we do matters. What we preserve matters. What we pass on matters. So think about it. Think about what you would preserve. Think about what knowledge you would write down, what skills you would teach, what stories you would tell. Think about what you want to leave behind. Because someday someone will find it. Someday someone will dig through the ruins of our civilization and wonder who we were. They'll find our artifacts, our buildings, our books. They'll try to piece together our story, to understand what we knew and what we valued and why we disappeared. What do you want them to find? What do you want them to know? That we were aware of our fragility and we tried to do something about it. That we valued knowledge and worked to preserve it. That we learned from the past and tried to build something better. Or that we ignored the warnings, assumed we were different, and fell like all the others. The choice is ours. The time is now. The world is waiting. The future is watching. The cycle continues. And somewhere, beneath the waves, beneath the soil, beneath the layers of time, the ruins of forgotten civilizations wait in silence, holding their secrets close, whispering to anyone who will listen. Listen. learn, remember, and maybe, just maybe, we'll get it right this time.